ऑडियो क्लियर है? So very good afternoon. Had to wait for getting the presentation photographs right. As for the 5-minute delay, now the connection is set. So let me give you today's lesson plan, a continuation from yesterday. Then we'll be stepping on into different domains. So first we'll start with properties of pressure belt. Okay. So we have 4 to 5 properties of pressure belts. Once this segment is done, then the rest of the session will be dealing with 4 climatic regions: equatorial, deserts, British, and finally Mediterranean. Is it clear? So those few climatic regions should take a good chunk of your time. If this is done, then I'll give you the lesson plan, which is after that. Okay. Tell me whether you're ready. Shall we proceed? So post pressure belts, the larger chunk will be with climatic regions. Okay, fine. Thank you. So let me start with properties of pressure belt. So yesterday we saw 4 pressure belts, right? So they have certain properties, something which can be universally applied, and there is one special pressure belt. We'll see that also. Is it clear? First point is fairly simple. They exhibit more or less uniform pressure. More or less uniform pressure. Okay. So when we say more or less uniform pressure, you say one region as a high pressure belt area, then in the entire parallel or the region you travel across any part of the world, you will be experiencing high pressure. I say low pressure, everywhere it is low pressure. So more or less uniform pressure. Makes sense? So example, we saw equator yesterday, where be it in South America, Africa, or in Indonesia, you'll be having the same pressure. Number 2, this is interesting. Pressure belts are not perfectly parallel, but broken and wavy. Write it down, we'll see a simple reason. Pressure belts are not perfectly parallel, but they are broken and wavy. Okay. See, the meaning is simple. You try to draw a latitude for any region. For example, okay, let's take this is Africa, and this will be equator passing through Africa, straight line, without any problem. Now, if you take your pressure belts are not going to be parallel to your equator. They operate something like this. They'll be like this. Maybe the visibility is less. Go to the next page. So if this is going to be my continent and this is my equator, my pressure belt will be something like this, Okay, not perfectly parallel, but kind of broken. In certain places, broken meaning you won't have the low pressure You will have the low pressure region, of course, but not uniformly connected. Example, you can take the islands of Indonesia. Fine. So because you have land and after land you have water. The reason why it is quite wavy and not perfect is because of differential heating of land and water. Look back to property of water, we find this. As land and water heat up differently, even if the same amount of insulation is present, Africa will not heat the same, similar to your Atlantic Ocean. Same as the Indian Ocean. Indian Ocean and Atlantic Ocean may be made of the same material, but even if it is water, size of Indian Ocean, size of Atlantic Ocean, everything is going to change. So because of that, each of them will exhibit different characteristics. So if there is going to be a change in temperature reception, differential heating, then naturally my pressure system will be different. I believe it makes sense. The reason is differential heating of land and water. Even if there are two water bodies, no two water bodies are same. Their size will be different. The heating capacity will be different. Point number 3. See, before I tell you the point, let me draw this small one. Let's take a bench. People sitting over a bench. Okay. We draw a bigger bench. Hold. Is it clear? Now, picture a condition where I'm standing here in blue color and I go near the table, take coffee and start pouring coffee. Okay. So when I start pouring coffee, you tell me what will the person 1 do? He can't hit me. I control the diagram. Okay. So when I pour coffee, what will happen? Yeah, logically, that's what it should happen. No? He should move. He can't come and beat me. I control the diagram. If he comes in, I will kill him. Okay. Yeah, see, logically speaking, 4 people are sitting. And if there is going to be any problem in one section, first person says to second person, move and sit. Second to third person, move and sit. Third to fourth person, move and sit. Finally, fourth person will move, third person will move, second person will move, first person will move. This is clear. You'll get up from the place, you move away from the seat. Okay. They'll move and sit because bench there is still more spacing. That's why I drew a larger bench. Get it? Any doubts here? Any doubts here? This diagram. Any doubts? இது புரியலன்னு வைங்களேன். Any doubts? No problem, right? Nothing. Just people moving. That's all. See, understand. These 4 people are the 4 pressure belts. Okay. And we need to discuss what exactly is the coffee in this diagram. See, the property is this. Let me draw the diagram, then I'll write the property. I'll write it first. Pressure belts are not fixed. Not fixed. And they shift to northern hemisphere during summer and to southern hemisphere during winter. Southern hemisphere during winter. We'll see why. Listen, I'll give you time to draw the diagram, no problem. See, this is the ideal condition. Equatorial low, subtropical high, subpolar low, polar high pressure belt, no change. But if you think about it, I was able to draw this diagram based on one simple assumption. I assumed that sun's insolation is exactly concentrated in the equator. Is it not? Only since there was high temperature in equator, I came to a conclusion based on equator, the 3 pressure belts are there. But you yourself know this is not true. This is true only during equinox. Apart from equinox, the area where the direct sunlight is present, the area of maximum insolation, keeps shifting between my summer season and winter season. So please know this is possible only for 2 days exactly, or most of the time period. But there is variation. So this is my equatorial hit, equinoxes. Apart from this, I will have a summer season, right? So during summer, see what happens. Equator. This is my winter. Okay. Same diagram. Southern hemisphere. Got the idea? Now during my summer season, let's take the extreme position, summer solstice. my sun's overhead will be a Tropic of Cancer here, right? Tropic of Cancer. So once my insolation moves to Tropic of Cancer, naturally, okay, please understand my pressure, low pressure area was created only because of sun's insolation. So if the area of sun's insolation itself is shifting up, temperature, high temperature governs low pressure. If this itself is shifting up, then automatically my low pressure system will shift north. First person moving up due to coffee pouring. First person moves up, automatically second person will move up. After second, third person moves up. Please note, it's not possible for the fourth person to move north of the earth. Nothing is there. What will happen is this surface area will shrink, become very, very small, the high pressure belt. During winter season, the reverse happens. Please note, both are contradictory. Contradictory meaning for both the hemispheres. So northern hemispheres, when the pressure belts are moving up, okay, southern hemisphere also they begin to expand up. Now listen carefully. During winter season, sun's insolation is at Tropic of Capricorn. So my insolation will be right here, Tropic of Capricorn. So once it reaches Tropic of Capricorn, naturally low pressure belt will come down. So low pressure belt shifts below equator, high pressure belt comes below, subpolar low pressure belt comes below. Now polar high pressure belt has a large area, it expands really well. Expands. So here it is contracting, here it is expanding. So that is why I've written, read the verse again. Pressure belts are not fixed and they shift to northern hemisphere during summer and to southern hemisphere during winter. That's all. Take this down. Once you've done, take in the diagram, use the word finished. Fundamental principle, surface temperature influences air temperature. Area of insulation moves, naturally pressure belt will move. Okay. And what I was doing is I was telling you it was complementary. Meaning, northern hemisphere, if the pressure belts are shrinking, southern hemisphere, it will expand. Northern hemisphere, if it is expanding, southern hemisphere, it will contract. So the diagram will be opposite for both hemispheres. Okay. Not blocking anything, I believe. The two responses. One more response, I think I'll proceed further. See, this principle will come in handy. Okay, we will use it. Ready? No, faster. Lot of ground to cover, people, today. And I'll tell you, you're going to enjoy climate like anything today. Mother promise. Okay. Serious, like once you enter climatic regions only, now we're moving from physics to real geography, real world. Thank you. So point number 4 is an extension of point number 3. Okay. I've just told you pressure belts shift, but please understand within pressure belt shifting, there is a variation. Listen. The shift of pressure belts, a derived point, shift of pressure belts is more in the northern hemisphere, and less in the southern hemisphere. Less in the southern hemisphere. I'll tell you the meaning. Simple. See, the equator is a reference point, right? So with equator as reference, if you're trying to understand how much shift is actually happening, see, in the northern hemisphere, the sun's insolation can go exactly till Tropic of Cancer. Tropic of Cancer, high amount of insolation, 23.5 degree north. If that is the case in northern hemisphere, the equatorial low pressure belt can actually move close to 23.5 degree north. The shift will be very prominent. How much ever insulation is there in terms of latitude, the low pressure belt is going to shift. Sorry, it's not in a good position. The low pressure belt is going to shift really, really well. Very good shift. 23.5, good. 22, 23.5. But you take the reverse case during a winter season, even if sun's insolation is overhead at 23.5 degrees south, the shift will be quite less. Very, very close. Approximately 5 degrees south, 7 degrees south, very, very less, but very, very large. Why do we have this discrepancy between north and southern hemisphere? The answer is simple. Two reasons. First is differential heating of land and water, and second is about distribution of land and water. You yourself know clearly, you take northern and southern hemisphere. Southern hemisphere is simply a water sphere. There is so much domination of water. And even if you start heating water, water may not exhibit the pressure immediately. It will take a very, very long time. That is the reason the pressure belt doesn't shift properly, because it is mostly made of water. Southern hemisphere, domination of water. But if you take land distribution, northern hemisphere is totally different. Think about the diagram again. Your North America, half of Africa, Europe, Asia, and of course, the entire region. You take Antarctica, Antarctica is far south. Australia is even a smaller continent. So most of your landmass is actually present in the northern hemisphere. So you heat land, land will immediately get heated up faster. So proper shifting of pressure belts. Here it is water, northern hemisphere it is land. That is the reason you have this variation. Okay, so we just got one more point. 1 point. Tell me whether you're ready. Last point. After we'll go to climate. Regions. So differential heating of land and water and distribution of land and water. Water is dominant here. That's why. Thank you. So last point. Now this is special. Okay. Of several pressure belts, we are going to pay attention to one single pressure belt. Okay, it is called the intertropical convergence zone. It is nothing but your equatorial low. We'll understand why it is called by a different name. Okay. Intertropical convergence zone. ITCZ. Got it? So intertropical convergence zone is nothing special but your equatorial low pressure belt. It's the zone of low pressure. Zone of low pressure located ideally between 5 degrees north and 5 degrees south. Is it clear? Got it? So now we are going to understand an important character of this ITCZ. So this is my equatorial low. On both north and south of it, you'll get subtropical high pressure belt. We saw that yesterday. Subtropical high. Here also get your subtropical high. Right? And between my equatorial low and subtropical high, yesterday we saw wind system. Name is trade winds. Now let's get the meaning of this term correct. Intertropical. That is located exactly in the center of tropical region between 23 and 23. Intertropical convergence zone. Convergence. See, this is the region where wind systems of the northern and southern hemisphere meet. All the northern hemisphere wind systems will be north of ITCZ. Southern hemisphere south of ITCZ. Meaning makes sense. So what important character are we talking about? Well, for that we need to look at ships. See, let me draw two ships for you. Take a different color. One ship is somewhere here. Okay, between ITCZ and subtropical high pressure belt, one boat or one ship is exactly at intertropical convergence zone. We'll see what happens. Same diagram, I'll draw it like this. As usual, vertical will make it horizontal. Okay, so 0 degrees, 5 degree north, 5 degree south, 10 degree north, 10 degree south. Is it clear? Now, trade winds are moving from both northern hemisphere and southern hemisphere. We used blue color arrow marks. Listen. Blue color arrows moving in. Blue color trade winds moving in. Now, this is when you appreciate an important parameter. See, fluid systems are not things which bounce off. So you take a solid, I throw a ball at you, it will hit you, and after hitting you, it will bounce off, right? That's not the same thing in fluid system. If you take a pail of water and throw the pail at you, of course, a large section will hit, but at the same time, it will diverge outside. Now, from liquid, I'll go to gas. Take a bucket of gas and put the gas at you. You think the gas is going to hit you exactly? Not exactly. It's going to diverge out. See, listen, It's not necessary that these wind systems, the advection wind systems, need to exactly hit the equator, and only after hitting the equator they will move up. That's not a cricket ball. Okay, it's gas, that's all. Got it? So when they come to 5 degree north and 5 degrees south itself, they are experiencing very, very high temperature. So once you experience high temperature, think back, surface temperature influences air temperature. So by 5 degrees itself, they start to move up. So they move like this. Not necessary I should hit this area. Get the idea? See, you take the zone of intertropical convergence zone, you clearly see it doesn't have winds. You don't have winds. You only have vertical movement of air. Got it? Now let's draw the two ships which you put there. One ship is between ITCZ and subtropical high pressure belt. So maybe the ship is right here. Maybe the ship is right here. We call this 1, we call this 2. You tell me between 1 and 2, which ship will move because of winds? 1 and 2. Who can move? Who can move? One person again giving wrong answer. I'll take fan and keep it in your face. Only then you'll understand. See, look at the only number 2 can move, isn't it? Because he's the only one who's experiencing winds. Is it clear? He can move. If you're standing, air is rising from here, air is rising from here. You want wind system to push either your left or right side. Only then you'll move, isn't it? Where will you go? In the sky, a Superman. You understood? Here, nothing is going to happen. Nothing is there. If you're trapped in this region, see, don't tell me, sir, I have motorboat or motor ship. If you have motorboat, you drive. I'm talking about ships and boats who are completely reliant on the movement of winds. This will escape. 2 has no problem. 2 is very normal. First condition, it has absolutely no other opportunity. It will simply stay. If you're a sailor using a yacht or any boat which is completely reliant only on wind system, there are chances that close to 10 to 15 days, if you don't have food, you might actually die because winds are not going to help you. Maybe you expect some motor ship to come and save you, maybe a diesel engine. Got the idea? This region is called as doldrum. That is why. This zone is there, no? One more name. This is called as doldrums. Doldrums means there is no activity. No activity. So in doldrums, please note, there is no winds. Air moves vertically. Here only there is winds. Example in a statement, Indian Parliament is in doldrums. They're not doing anything. Is it clear? Okay. So that ends the fifth property. So ITCZ and doldrums, one and the same. ITCZ is characterized by inactivity, so it is called as doldrums. That's all. Why exactly this happens in 5 degree north and 5 degree south? See, I took this again, look at the word right here. Ideally, because this is where you get the highest temperature. Air is rising up. Think back, low pressure belts. That's it. Low pressure, air rising up. Is it clear? Okay. Ma'am, there is no pressure forcing, ma'am. No one is coming, nothing. That's simply moving up. That's all. You will stand. No one will touch you. Was it clear? See, please note, ITCZ will move. Look at the word right here. I've used ideally. Why does it move? We saw property 3, property 4. Pressure belt is shifted during season. During summer season, it will move in north. During winter season, it will come towards southern hemisphere. We saw on the previous property, no? ITCZ will shift. Okay, ideally only it is located. That's why this keyword is important. This is the equatorial low pressure belt. It will shift. Shall we go to climatic regions now? Ready? Never ever forget, doldrums is a subset of ITCZ. Yes, that's the right way to understand. Good. We call ITCZ as doldrums because there is inactivity. Okay. You can also say doldrums is another name for ITCZ. It is true. Okay, both the names has meaning. Convergence zone meaning both the air masses are converging. That is why you call it ITCZ. You call it doldrums because there is no wind. Both mean one and the same. Now let's go to climatic regions. Now this is when we discuss about Gocheng Liang. Oh, sorry. Go Ching Leong book. If you have the book, well and good. Because I told you long back to purchase. Is it clear? So Go Ching Leong has two parts. If you're in the index page by any chance. Okay, I think the first 12 chapters. First book is solid. Go Ching Leong. Okay, Certificate Physical and Human Geography, index page. Let two parts will be there, part 1, part 2. See, part 1 will be your geomorphology. Part 2 will be your climatology. Listen very carefully. Part 1, 12 chapters will be there. Don't read. I will explain why. UPSC has not asked questions from part 1 for the last 8 years. 8 years, I mean it. You don't have any other importance from this section also. So how to approach it? Selectively certain parts only need to learn. How to approach it, I will teach you when we come to geomorphology. Climate, we are only in climate. Geomorphology, I'll need 2 sessions. That time I will talk about this. Now need not worry about this at all. 1 chapter or 2 chapter I only need to read. We'll do it at the last. Clear? Don't again send me emails, should we read chapter number 7, chapter number 8. I told you don't, not don't. You want, you learn. No, exam not required mostly. Second part, starting from chapter 13, I guess, I believe it is 13, our major focus of climatic regions will be from 15 to 25. 15 will be equatorial climate to Arctic climate. That is what we need properly. This is relevant for your mains exam, not just your prelims, because it will tell you how industries will develop. We will link it with human geography. Yesterday I was insisting, isn't it? Physical geography encases human geography. So that's the point which you will understand. So before 15, you'll have 2 chapters, 13, 14. Both of them will be climate, I believe. 13, 14. 13, 14, Nana. 13, 14 is climate chapter. No, people tell me. No one has book people. Yeah, 13 is weather. Okay, so 13 and 14 is climate. Again, listen, 13, 14, it's not highly insistent that you read it. Why again? Content from 13, 14 chapters will be already there in fundamentals of physical geography. The NCERT, 11th standard NCERT, which you are already using. If you have read that thoroughly, 13, 14, really not mandatory. But you feel like, no sir, I just want better clarity, I want additional information, you can read. But same content, similar content will be there. Yesterday, one person asked regarding clouds, right? Clouds will be in 13, 14 only. Okay, so you can go through these, but there won't be anything to memorize as such, because already physical geography you're reading the notes also. Not required, optional for you. You feel like you want better clarity, read. No one is stopping you from learning. Got it? My entire focus will be for these 11 chapters, which I'm concerned about, 15 to 25, is the climatic regions, which will go one by one. And today we are planning to finish 4 climatic regions, after which we go to jet streams and cyclones. Okay, 13 is weather and 14 is climate. Thank you. So this is left to you. My focus is on this. You're learning NCERT well. This is not mandatory. Clear? So now let's go to climatic regions. Fine. First, take this chart. Okay. The chart is already there in Go Ching Leong, but anyway, want it in the notebook when we start first. Okay. 0, 10, 30, 45, ideally 65 to 70, 90. There are totally 11 climatic regions in the world. Equatorial, desert, British, Mediterranean. Remember Mediterranean Sea? Southern Europe, North Africa, Savannah, Steppe, Siberian, tropical marine, tropical monsoon, tropical marine or tropical monsoon, north of China, Laurentian. Finally, polar climate. Okay, totally 11 are there. This is the astrology map of the world. Astrology map means when you go to your astrology, you will say, This star is sitting in square number 7. He's in number 4. Life will be nothing will happen. See, that is not science, pseudoscience. This is science. Like if anyone tells you, sir, I'm from the western part of the continent and western part of my continent, and I come at 35-degree north, then you can pretty much sure he's coming from a climate where there is winter rainfall. Okay, you can say that natural vegetation or the type of trees in that area will mostly be dominated by shrubs. You get it? See, because this will give you an analysis of temperature and precipitation characteristics. A person tells you latitude, and along with latitude, he tells you he's from western part, central part, or the eastern part of your continent. Then you can pretty much tell his entire astrology. Basically, that's why he said astrology map of the world. I will finish the climatic regions, then I'll tell you how to fix this chart in any continent. You fix the chart in the continent, then any climate you can learn. That will be the last segment of climate. Clear? Greece, Turkey oil problem in East Mediterranean Sea. Correct. Bilateral people. If you're ready, I'll start with the equatorial climate. Okay, first one. Good. This will be the format. Every climatic region, we start with the map. Those who have the book, they can go to chapter number 15. 15 chapter, hot with equatorial climate. First, we'll start with the map. After the map, we'll see something called as climograph. I will show you the climograph. Please wait. I'll tell you what information is there. Post climograph, what is the natural vegetation and relationship with biodiversity? After natural vegetation and biodiversity, we'll be looking at economic development. This economic development part is there, no? This is only the human geography part. I was insisting yesterday, no? Like we'll be seeing this in climate, seeing this in climate. That is why I tell you when you read GCL, please be very careful. Okay, it helps you both for your prelims and mains. So first climate we are going to start is the equatorial one. Equatorial climate, chapter 15. Those who have the book, simply open and keep. Equatorial climate. So based on a climate chart, it's right here. Equatorial, 0 to 10. Let me open that for you. Where is my... Yeah. So let's get one by one. So first, let me tell you what is the meaning of the climograph. I didn't tell you the meaning. So let me present you the meaning first of all. Yeah. See, climograph gives you information on two things. I believe you can see this chart. There are black colors and there is a y-axis and x-axis. Every chart, you know the x and y-axis I've told you. The entire problem is solved. Climograph gives you information on two things. First, what is my x-axis? X-axis is nothing but my month name. That's all. January, February, March, ending till December. So you'll totally find 12 values. Got it? What we're trying to monitor is for each and every month, two factors. First is what is my rainfall for every month. Okay, that's my first y-axis. So rainfall is indicated by these bar graph. 1, 2, so month, January rainfall, October rainfall. This is April rainfall, each and every month. So based on that, you'll be getting different heights. Got it? Number 2, the second one. Second one is about temperature. We saw this already. Average temperature or mean temperature for every month. Remember, sum of the values divided by number of values. So what is the average temperature of May? You know where it is marked? It's marked on top, right here. Average temperature of May. Average temperature of June. Average temperature of December. So each and every month they can find average temperature. You already have it in your notes. Please check relation between latitude and temperature. Above that, you have written 3 different definitions. Is it clear? So what they'll do is, Totally again 12 values will come. So those 12 values, they will connect and make one line. Is it clear? So this will tell you about change in temperature. That's all. So two factors. First is my mean temperature. First is my rainfall indicated by the black colored bar chart. Second is my average temperature for each and every month. Now let me proceed to the map first as usual. So first you need to visit different parts of the world where you experience equatorial climate. Yeah, the map is fairly clear. Just hold on. Okay, now I just needed the display so that I can see that you can see, because once you're using photographs, you need to be careful. See, every map will tell you this. So first you're going to start with equatorial climate. Is it clear? So equatorial climate is found between 10° north and 10° south in both sides of the equator. Is it clear? So 10° north, 10° south, ideally. So let me, again, see, since map reading is done, map reading, you tell me you ever forget, I'll go and kill you. Is it clear? Map reading should immediately come to your mind. All the countries which I tell you. If you have your map reading notes with you, well and good. Is it clear? So look at the countries right now. Parts of Colombia, Ecuador, large part of Brazil, okay, the Amazon forest, which will spill over to the remaining countries. Certain parts of West Africa, remember Sierra Leone, Liberia, Togo, Benin, Ghana. So all of them, along with the Central African Republic, Congo. Okay, so Gabon. So those come under equatorial climate again. And moving to the eastern part, you take Indonesia, Java, Sumatra, Borneo, Sulawesi, and of course the Malay Peninsula. Large part of Malay Peninsula will fall under equatorial climate. So thing is, that's what I told you. You can be in Brazil, or you can be in Congo, or you can be in Indonesia. Climate will be same because the latitude is same. That's the beauty of it. The first thing you'll always try to understand is, when I take a climate, even though certain aspects according to geography you expected, you would not see that the country is experiencing the climate. For example, you clearly see that equator is moving through this section, right? The blue color area where I'm actually marked it. So equator moves through Eastern Africa also. But the problem is, this area which I've highlighted in blue does not experience equatorial climate. Same thing here also. You take this South America, between the two regions, there is a gap in the middle. There is no equatorial climate. So can anyone tell me why, in spite of equator passing through, you don't experience equatorial climates in eastern part of Africa and in a segment of western South America? Why don't you experience that? There is one CIAN 19 batch student. Gobi, good answer. Very good answer, Gobi. On point, on point. See, the answer lies in altitude. Okay. Think back again. With increase in altitude, there is decrease in temperature. So the diagram goes like this. So first, anomaly. We're appreciating why certain areas do not experience equatorial climate. See, the point is, Congo is here. Ethiopia will be here. This is what we saw, hop over Ethiopia, Ethiopian highlands. Ethiopia is here. You take Kenya, large part of Ethiopia, large parts of Kenya, including Tanzania, will actually be elevated. Since they are elevated, think back, with increase in altitude, temperature will decrease. So once temperature decreases, you won't experience equatorial climates because of altitudinal variation. Here there'll be high temperature. So you can ask me, if this is the case for Africa, the eastern part is slightly up, what could be the reason for South America? South America, we got even a simpler answer. In parts of Ecuador and Peru, on top, you might have glaciers. You know what we're talking about? Andes Mountains in South America. Andes Mountains are quite tall, average height of 4,000 meters. So they're very, very tall. So again, with increase in altitude, you go up the mountains, temperature will decline. That is the reason you don't find equatorial climate in these regions. So that's point one. So in parts which equator flows through, you get equatorial climate. Two exceptions include East Africa and the region of Andes Mountains. That's point one. Right? So now we're going to talk about climograph. I believe you're ready. So now let's go to climograph. So first map is done. Second one, right here. See, I think in your textbook you'll find two maps. Fine. See, in this particular climate, it's not really special to look at both the maps. Okay, because northern hemisphere and southern hemisphere. That is why they give you two maps, and both of them will give you the same information. What we are more concerned about is how the rainfall graphs look like. You see that? I've clearly told you that your yes, your black color bars indicate rainfall. So be it January, be it June, be it December, in each and everything you have your black color rainfall graph, isn't it? Which means there is rainfall throughout the year. Throughout. So this is the first climate which we come across where there's rainfall throughout the year. See, thing is, not just rainfall throughout the year. There is a characteristic in this rainfall. Let's say you're living in Congo. You're a Congo citizen. So every day in Congo, every day in Indonesia, every day in Brazil, 5 p.m., 5:30 p.m. If you go outside your house without umbrella, you will die because rainfall will pour. High amount of temperature, extremely high temperature. Due to immense amount of temperature, convection. Due to convection, cumulonimbus clouds. Due to cumulonimbus clouds, thunder and lightning. Air passes like it won't be rising like small bubbles. Entire region, you take square kilometers, entire area air passes will rise up. They'll form very big clouds. Thunder and lightning will be there. We get rainfall every single day. Is it clear? So rainfall every single day, rainfall throughout the year, 365 days of the year. That's character 1. Got it? Coming to number 2. This is an interesting point. Now think back to the definition of seasons. Season is a time period which has similar temperature and precipitation characteristics. So you take summer, there should be high temperature, winter there is low temperature. See, the beauty of equatorial climate is throughout the year, 365 days. 365 days of the year. Think about my insolation. My insolation will be focused only between 23.5 degrees north and 23.5 degrees south. Correct? Now, due to this immense amount of concentration of heat, there is so much of temperature which is right here. So it does not matter whether you are in May. It does not matter whether you are in December. Every single month there will be high temperature because my sun's insolation is concentrated only there. Sunlight does not leave anywhere. It's always there. It's like you want to escape somewhere, but sun won't allow you. When you see that the sun is going to exceed northern hemisphere, after hitting 23, again he'll come back. Directly hit your face. Meaning makes sense. So please note, every month you try to measure average temperature. Average temperature will be consistently high. That is why you get a pretty much straight line. If there is variation between summer and winter, summer temperature will increase, winter temperature will fall. Be the same temperature. Is it clear? That is why we say there is no concept of season in equatorial climate. Meaning makes sense. There is no season. Season means between summer and winter change will be there. No summer, no winter, no autumn, no spring. Nothing. Is it clear? That's the speciality of equatorial climate. So in prelims you get a statement that this climate has no season. Close your answer and hit equatorial climate. That's all. Okay, so that's point 3. It's point 3. So points 1 and point 2. Now within this we have the third point. Tell me, are they ready? 3 points are done. First is variation map. Second is temperature. Third is rain. Second is rainfall. Third is temperature. This is called convectional rainfall. The method which I told you, where I told you that air parcels will rise in large numbers, and after rising in large numbers, there is formation of clouds. Why this happened? Because of high amount of heating from the sun, high temperature. This is called convectional rainfall. Convection is vertical transfer of heat. So first type of rainfall I'm introducing you. First type of precipitation. Yesterday the 4 things which we saw was forms of precipitation. This is the first type of precipitation. There are 3 types. Okay. Convectional rainfall or convectional precipitation. So ready? So be it in Congo, be it in Brazil, anytime you go as a tourist, umbrella are required every day. Else you will die in the evening, especially if you go out. And rainfall won't be drizzling rain. It will pour and hit your head. You lose your hair also. Heavy rainfall. Right. So thanks for the response. We'll move to the next point. Next is we try to understand that there is very slight variation, not noticeable, but very slight variation. You get those things only if you get the climograph. See, even though there is rainfall throughout the year, there is some extremely slight variation. 2 months alone, you'll be having slightly higher rainfall, right? You take this one. These alone are taller. This is called double rainfall peak. Double rainfall peak. So you can see that it happens in the months of April and October, immediately after the equinoxes. Immediately after the equinoxes. Okay. Now think back to equinox dates again. June 21st, March 21. Right? So these are the dates. Think back again. Even though sun's radiation is concentrated between 23.5 and 23.5 throughout the year, within 23 and 23, 12 months late is between 23 and 23. There is no doubt. But within those 12 months, there is a 2-month time period where the concentration is even higher, where it's very, very close to equator, between 5 and 5. You get the understanding? 12 months concentration between 23.5 and 23.5. I'm saying within these 12 months, there is a subset. The subset is 2 months time period where it is concentrated between 5 degree north and 5 degree south. So compared to my remaining 10 months, there'll be even more heat. So there is more heat, automatically, rainfall will increase. There is more insolation received from the sun. It's called as double rainfall peak. One more question would arise in your mind. So why do we say immediately after than the equinox? Because on June 21st, why can't it be June 21st itself? That's when you understand time delay. See, please note, you want to make sure you heat the entire air belt spread across several square kilometers. It will take some time for land surface or water surface to transfer that heat to the atmosphere. So that is why there is a slight time delay, because you're dealing with a larger Earth system. Meaning, makes sense? Larger Earth system. Now, next time going to biodiversity. Tell me, you ready? See, since I'm using maps or names, I don't know how many of you have the book. So just have to be careful, that's all. Okay. Yeah, thanks for the response. Now let's go back to the blackboard again. Please get this understanding right. In equator, biodiversity is very high. You go and ask an individual, why is there high biodiversity in equator? They will give you this answer. Well, they will tell you, there is high temperature in equator, there is high rainfall in equator. If there is high temperature, high rainfall, plants will grow really well, animals will be there, animals will feed on plants. So high number of plants, high number of animals, so high biodiversity. Please note the answer is wrong. Listen carefully. High temperature, high rainfall, I do agree that population of plants will increase. Population of animals will increase, but that does not explain why biodiversity is higher. You get the meaning? See, but this is a related reason, but not the exact reason. Listen carefully. Due to high temperature, due to high rainfall, there is more population. Because of more population, there is more competition. There is more competition, and because of increase in competition, biodiversity will increase. Take this simple scenario. We'll take two trees which bear two different types of fruits. One fruit is very tasty. This is where birds like to feed. One area is not very tasty. Is it clear? But still, it's present. It's a plant after all. Let's say that of 100 birds trying to feed in this original tree, only 90 birds have the capacity to climb them properly. 10 birds are very weak. What will the 10 birds do? 10 birds will come to the secondary tree. They'll start climbing here. And after climbing here, they'll begin to eat the fruits here, even though the fruits are not very good. even though there are spikes in the tree. It's very difficult to climb. Let's say somehow they try and climb it. Out of 10 birds, maybe 2 birds die because they don't have the ability to climb. Now, 8 birds are remaining. Over a period of time, these 8 birds which are present in second tree, they will start to reproduce among themselves compared to the general population. These 8 birds, once they survive and reproduce, try to fast forward for 1 year, 100 years, 1,000 years, millions of years, over a period of time, this will become one individual species. You get it? Due to competition, the birds had no other option, but they had to specialize for a different tree. More competition leads to more specialization. Because once I specialize for a not so tasty fruit, these people are not going to fight against me. So increase in specialization. Due to increase in specialization, there is increase in biodiversity. This is the link. Is it clear? Increase in competition. Due to increase in competition, there is need for specialization. Need for specialization will increase biodiversity. There is no other option. If you are in equatorial region, it is better you become a new species. See, there are plants, there are birds who live only in the top of the tree. Certain plants and animals will only feed on the middle portion of the tree, certain only at the bottom of the tree. There are so many ant species. Okay, you take one tree in equatorial climate, count the number of ant species which is there, and you go to England, fine. You take the entire island of United Kingdom itself. You take both the British Isles, the entire British Isles, you count the number of ant species. I'll tell you, the number of ant species in one equatorial tree will be more than the entire island of UK. You get the idea? So that's the power of biodiversity in equatorial region. So competition leading to specialization. Moving further. So if you're going to have more and more biodiversity, then your plants are going to be very, very diverse. So look at your natural vegetation. The natural vegetation is tropical evergreen forest. Tropical evergreen forest. Okay. So we have several trees of several heights. You have taller ones, middle ones, tall lower middle ones, middle ones, middle lower ones, low ones, lower middle ones, lower lower ones. So many trees will be there. So because of competition, there are so many plants trying to fight for sunlight space. Okay. And some species are very good in muscling out the other plants. They will grow really tall and they'll try to get the maximum amount of sunlight. They try to spread open the areas. Okay. So I've drawn the diagram only for the right side. Same thing is applicable for the left side also. So picture a condition where so many trees are there. Everyone trying to capture as much amount of sunlight. Sunlight penetration will be extremely low inside the forest area. You are inside an equatorial forest. You might be in complete darkness. Let's show the picture first of all. Let's go to Amazon canopy. Okay. Right there. See, this is the problem. Amazon.in. I'm going to kill these people. I'm really going to kill these Amazon people. I want tropical rainforest. Ah, there it is. See that? That's your tropical rainforest. And the variety which you find right here is so high. And you can clearly see that it's totally dark on the inside. Why it is dark? Because sunlight gets captured. This is canopy-based arrangement where there is severe density of plants and you have this layered structure, layered arrangement. Those who have the book, I think you can see the picture also. Okay, there'll be a picture given. Is it clear? So very, very dark and dense. Okay, 6366. Thank you. So dark region. Now in this, we are going to appreciate an interesting fact. Meaning of the word evergreen. Need to get this idea clear. Let's go back again. What do you mean by evergreen here? You understand. So evergreen means the forest is always green in color. That we know. But why exactly? Immediately the answer will come. Sir, it is evergreen because maybe plants don't shed their leaves. If I don't shed my leaves, leaves are always present. So I will be an evergreen forest, right? See, please understand. Please understand that is not the explanation for your tropical rainforest. In tropical rainforest, a crucial point is plants shed leaves. Plants shed leaves. Listen carefully. The reason is because of canopy-based arrangement. Both are related. That is why I finished canopy first. See, you're receiving sunlight for your photosynthesis process. Once there is photosynthesis, good production. Normally what a plant will do, they start to reproduce. If you start to reproduce, what do you produce starting? More and more flowers will come, right? More and more fruits will come. See, producing fruits and flowers is a part of a plant's life cycle. After reproduction, there will be some temporary time period where leaves will be shed. Leaves, not the entire plant is going to shed. Some section of the plant is going to shed its leaves because its reproductive, one cycle of reproduction is complete. Or a temporary hiatus will be there, where leaf shedding is there. You know what will happen? When there is some temporary gap here, somewhere, let's say gap is there, sunlight will be able to penetrate through the gaps, reach the second layer of canopy. Here plants will be there, here also plants will be there. Okay, what will happen? These two areas, fine, they will receive sunlight, photosynthesis, they will start their reproductive cycle, flowers, fruits. Cycle over, they will shed leaves. Then sunlight will penetrate even deeper. See, this won't happen simultaneously. This process will be happening in different levels in different parts of the forest area. Because so many species are there, each species will have its own reproductive life cycle, timeline, everything will change, height will change. So since the forest area is very large, since the process goes on at different levels in different time periods, any time you look at the forest area, only one plant will be shedding the leaves. If one plant sheds the leaves, there are so many trees which are present in the forest which will actually try to blossom and produce as many leaves as possible. Because after a very long time, they would get the opportunity to sunlight. You get the meaning? So please understand, plants are evergreen not because they don't shed leaves. They do shed leaves, but biodiversity is very high that the cycle do not match for every plant. So at one point of time, if one plant is shedding leaves, 10 plants will be having leaves. That is the reason it is evergreen. Is it clear? So if one is shedding, 10 will be having leaves. That is why it is evergreen. Okay. Different time periods because of canopy-based arrangement. Beautiful, isn't it? Now we're going to go to human geography part. See, human geography, automatically what should happen is you should link, okay, yesterday we discussed about population character, industrial characteristics, what will be present, what about settlement pattern. Immediately should come to your mind. The topics, major topics are the relationship will immediately get. Shall we? Economic development, human geography part. Listen. See, first we'll understand what major economic activity is present. And this is where you relate something, some problem with GCL. Does anyone know there is a problem in using Gosing Leong book? One problem is there. Does anyone know that? The book which you are using, no, there is one problem. I don't think anyone will tell you. I'll be honest, I'll tell you. New edition, ultra new edition, no problem. One problem is there. If you don't understand the problem, do one thing for me. Go to second page of the book. Second page, not page number 2. Second page of the book, and the opening less heading will be written. After heading, you just go to the second page. Tell me where it was when it was published. Tell me when it was published. Publishing year. And a Malaysian author, okay, that I know. When? I didn't ask who. 1974. You get the idea? See, people understand. You are using a book which is how many years old? 46 years old. Beauty is, they reprinted the book several times. You look at the word right there, reprint will be there. They never edited the book. They didn't change the data in the book. They've been publishing the same thing for 46 years. You know why? Climate doesn't change. Temperature pattern, rainfall pattern hasn't changed. If you go to certain chapters, no, they will mention USSR is there. In Soviet Union, this is what is happening. Please understand, the book is outdated when it comes to certain parts of human geography. Is it clear? That's the problem with the book. That's why I told you map reading notes is very important. The data I gave in your map reading class is 2000, as late I could collect, 2017, 2018. World exports and all those things I would have mentioned, right? Like this mineral, this metal, this industry as late I could collect. So for human geography data, your map reading notes will save you. So please note, data as such, numbers. Basically, an updation issue will be there. So that's why certain things which I talk about may not be there in the text, but that is updated, please note. So if you're learning geography, no problem. When it comes to physical geography, same material, that's all. Now let's talk about human geography. Think back again. See, high temperature and high rainfall presents an opportunity and a problem. And society is not same. Society meaning the people are not same who are living inside the forest area and who are living outside the forest. Meaning, if you're inside the forest, we are talking about tribals. Tribals have no other option. Their primary economic activity is this, inside the forest area. So many tribes are there, starting from Indonesia to Africa to Congo to Brazil. Inside the forest area, primary economic activity is hunting and gathering. Hunting and gathering. I believe the meaning makes perfect sense. High amount of biodiversity, so many animals are there. Hunt the animals. So many plants, gather food. No issues. And they are at a poor level of economic development because they do not have, since they are part of the forest area, they do not have exposure to modern developments largely. They remain isolated. And even if they do agriculture, they are only involved in subsistence agriculture. Subsistence agriculture. Subsistence agriculture means you're doing only at the basic level, just for feeding your family or just for feeding your tribe. Very, very basic level. Some tribals simply survive on hunting and gathering. Some tribals, maybe to a very small localized area, they take up subsistence. This is for inside the forest, away from modern economic activities. Meaning makes sense. Now, what about the areas which are getting modernized, which have modernized, which have your rural population, urban population living outside the forest area? Well, the major industry is this, outside. Major industries, plantation agriculture. Plantation agriculture. இங்கே தான் map reading notes இருக்கு. Map reading notes is there, just keep it with you. I'll recollect. See, countries I will tell you. Cocoa plantations. Ivory Coast, Ghana. West Africa. We saw? Ivory Coast, Ghana. Palm oil plantations. Palm oil. Malaysia. Indonesia. Is it clear? You come to Congo, Democratic Republic. You take Brazil, for example, parts of Brazil. Okay, again, coffee plantations. Is it clear? Get the idea? So these are again major producers seen in map reading. Since there is high temperature and high rainfall, these countries can easily go for these type of plantations. Now, some might be having a doubt on plantation agriculture. See, plantation agriculture is something where, listen, over a large area, you are cultivating and specializing only one plant. It is called industrial monoculture. Monoculture. Mono means one. Monoculture. So if you take cocoa plantations, now for acres and acres spread over a large area, only cocoa plant will be there. Plantation agriculture. Same for palm oil. They'll destroy the forest area, only palm oil will be there. That is plantation. Monoculture. Same plant over acres and acres. Can't even imagine how much is there. Got it? Now we need to understand some relationship, and apart from plantation agriculture, where else are they moving? So that addition I will do, and for that I need to talk about equatorial soil. Listen, equatorial soil is highly infertile. Let me explain. Wait, don't come for fights. Automatically you say, sir, this is not true. Biodiversity is very high. So many plants will die. So many animals will die. Once they start dying, so much biomass will be present. After bacteria and fungi act on this region, all that biomass will be returned back to soil. So once they get returned back to soil, soil will be very fertile. This is one part of the argument. You need to combine with one more thing. Even though the percentage of biomass decomposition rates, the decomposition rates in equator is 10 times greater than any climatic region in the world. Completely agreed. But please note, along with this, there is high rainfall also. Due to high amount of rainfall, the nutrients will get leached out. You can either erode the nutrients horizontally or they'll be taken up vertically. So high rainfall leaches nutrients from soil. Two questions will come. I'll answer it myself. First, you'll ask me, sir, but you only told us, I hate that word. Just now we discussed that there is canopy-based arrangement. Because of canopy-based arrangement, even sunlight penetration is difficult. If that is the case, how will water penetrate? See, please understand, this is an area where a canopy is present. So if there is going to be high torrential rainfall, torrential downpours, the leaves will cushion the fall and they will move across several leaves. When they hit the surface, erosion will be less. But please note, what would happen if one tree falls? Trees will die eventually at a point of time. Not even the top tree, middle tree. Let's say it falls. The level of soil is exposed, no? You just need few days of rainfall from the equatorial region to completely take away the soil, this region. Is it clear? So please note, this structure which I've told you is not permanent. Even if one tree falls, the entire patch of soil is gone. That's all. The erosion will be quite higher when it comes to nutrients. Second question, which should come to your mind immediately, if that is the case, how do plants survive? That is why we learn natural vegetation. Okay, natural vegetation is the plant development in an area over thousands to millions of years. They know the nutrient condition, they know to adapt themselves. That is why their root system will be very different. They'll be quite deep to even access nutrients which is beneath the soil surface. So even if soil is infertile, natural vegetation, a thick forest is very much possible because they've been evolving here over thousands to millions of years. Able to relate to it? Next question which you will ask me, sir, if this is the case, how is this possible? Modernization, fertilizer, irrigation systems. You can even have artificial shielding which can protect against certain types of areas. So they are actually doing plantation agriculture with large application of fertilizers. Is it clear? Because nutrients are limited. So please understand, this is natural vegetation. Agriculture is artificial. Artificial things you need to support. So if you don't provide the inputs, then this is also not sustainable over a period of time. Meaning makes sense. Harini, human geography part, it won't be human geography. Heading will be economic development. Chapter 15 itself, economic development heading will be there. I'm providing additional information. That section only I'm discussing. It will be there in your text also. Okay. Human geography, there is nothing. Chapter 15, within that it will be there. The physical geography, in cases human geography, how many times I've told you? People. Two more points. If you're ready, I'll proceed. 6366. Yes, you're right. Certain plantations like indigo have deep roots. Correct. Just two segments I need to handle. Then we'll close the climate and give you a break. See, first climate I'll need to take some time because I'm just setting you. So there will be more time spent. Other climates, as time progresses, will be much more comfortable. Okay. One more response, I'll proceed further. No, but point is, indigo is restricted right now, isn't it, compared to others? Because, artificial dyes, artificial paints have taken over. That's why. Okay. Response. Yeah, no, response not there. Okay, now it's come. Good. See, the 2 points which I wanted to add is apart from the general industry which is governed by climate, what other variation do you have? See, the variations can be seen with reference to Congo, Central African Republic, and Cameroon. Think back. DRC, it is not with reference to climate and non-climatic industry. If they ask you factors of industrial location, this is based on the minerals found. I think you remember. Cobalt. Okay. Now coming to Cameroon, Central African Republic, major industry was wood, logging. So this is quite unconventional. You usually don't go for wood industry here. We'll see the reason in Siberian climate. This is not advisable. but still they go because of high poverty. Coming to one country, set of countries on the eastern side, you take Indonesia, Brunei, and Malaysia. They have something which is apart from climate, oil and natural gas. Again, resource found as part of it. And please note the natural gas market, which you find in Indonesia, Brunei, and Malaysia, is quite a big market. They provide natural gas supplies to in and around the region. So these are non-climatic but existing industries in this region. Is it clear? And talking about population density, one exception is Indonesia. Maybe Brunei is a very small country, we need not talk about it. Apart from Brunei, apart from Indonesia, population density will generally be low for all the other equatorial climatic countries because of dense forest regions. Okay, I think this makes sense. Last point, so this is with non-agricultural but other industries. Last is with reference to a group of diseases called as neglected tropical diseases required for mains, both GS1 and GS2 and GS3 can be part of anything. NGTD, neglected tropical diseases. So please note, disease is anything which causes discomfort. Tropical, it is specific to the tropical region. We are talking about a large class of communicable diseases which is concentrated in the tropical region. You go to World Health Organization, you will find this list. The number of diseases is more than 100. What is the meaning neglected? Neglected means companies are not finding any solutions for these problems. Why don't they do that? Simple. Let's take two different diseases. Let's take one tropical disease and let's take diabetes. If you want to develop a proper drug which is efficient, you need to invest in research and development for more than 15 years. And even after 15 years, you may not succeed. It takes a long time to properly get an effective drug, a proper cure. Got it? Diabetes, if you're a company's head and you want to put so much of dollars, so much of time into developing a drug, between diabetes and some tropical disease in Africa or Asia, you would develop for diabetes. Why? Because regular customer, every day will consume. Second one, if the person has diabetes, means most of the diabetes cases are lifestyle diseases. They're not really moving, which means he has the capacity to pay. Nalla amount is there. Amount will be there. Is it clear? At the same time, long-term consumption. He starts consuming diabetes tablet for 25 years, 30 years, he'll come and purchase you only. You get the best tablet, very happy customer. Tropical disease, first of all, he will consume only if the disease is actually there. Okay, so first, if there is an infection only, he'll consume the disease. Second one, we are talking about poor countries. In poor countries, many may not have the capacity to pay. Capacity won't be there. Poor people. Number three, he's going to consume for a very, very short span of time, not a consistent customer also. So here also it is loss. That is why companies invest for diabetes, invest for heart disease tablets. That is why there are so many medicines in the market. They want to capture even that small share because people will pay for them. Tropical diseases are intentionally neglected. It is not that you cannot find medicine, but people are not interested. That is neglected tropical diseases. It's a major problem of equatorial region. One more significant problem which is affecting them is the problem of deforestation. When all these countries try to pursue economic development in one way or the other, which is severely burning the burnt, is your tropical evergreen forest. Is it clear? So I believe that ends the discussion on equatorial. Take a break for 5 minutes. I'll take you to deserts. Okay, 5 minutes. The two questions are there. So last point, one more time. Okay. See, last point, I believe you're talking about this one. See, the consumption by the individual will be for a very long time. So I produce a tablet, he will consume for 15 to 20 years. So useful for me. He's not going to do that. It's a very temporary process, not a long-term person. So you naturally invest in diabetes. Okay, so that is the reason we call them neglected tropical diseases. The reason being, the companies are not ready to invest because it is not financially worthwhile or financially not profitable. Coming to the last point, like after that, we were discussing about deforestation. See, when Congo tries to go towards industrialization, or let's say Cameroon goes for industrialization, let's take Indonesia. Indonesia, there is a problem of deforestation primarily because several regions are getting slashed out for supporting their palm oil plantations. Where is that? Palm oil, yeah, palm oil plantations. It's a severe problem in Indonesia. You take Brazil, for example. Brazil, soya plantations that teach you in savannah. So that's an issue everywhere. Okay. That was the point which you were asking. And second one is uh, whether there is slash and burn agriculture. So that's what we saw as subsistence. The reason why they go for slash and burn is tribals don't have, or they don't use industrial methods of farming. So a forest area is there, they just cut down the trees temporarily, and only for a short span of time they cultivate. Again, they go to one more area. Again, they go to one more area. They don't have a permanent, let's say, 3 acres of land for this tribal group. It doesn't work like that. They're part of the forest. So that's why subsistence, slash and burn agriculture is part of it, because tribals don't own permanent land. And number two, apart from them beginning to move, they don't use efficient methods in farming, the basic level, primitive methods. Next, last question. Now, something about deforestation. I think you got the point on deforestation. See, land, this is the biggest resource anywhere. You want to start to industrialize, be it port construction, factory construction, even for expanding your plantations. At the end of the day, you will need land, and fight for land will lead to deforestation, because it's only in the forest that people don't fight back. Most parts of the world, you don't have legislations which protect them. Only in India, only after 2005, 2006, we have Forest Rights Act, which provides right to tribals. Not many countries have that. Is it clear? Next, we need to move to the next climatic region, deserts. And climate chart. So we've done equatorial. This is done. We're going to western side, desert. First, we'll finish the western margin climates. So first of all, we need to get clarity on what exactly is a desert. Now, immediately, whenever we speak about deserts, the first thing which will come to your mind is heroes and heroines dancing in cinema, right? Because of us stupid directors. Because all their shots are shown in sand dunes. Sand will be there, hero will be there, hero will be there, they'll be running, butterfly something. Butterfly, graphics they will show, even in desert. Well, first thing, never ever make this mistake, ever. Desert is an area where there is very low precipitation. Very low precipitation, extremely low. Not even 20 centimeters in certain parts of the world. Desert can be hot or cold. Can be hot or cold. Please take this in mind. Every time I tell a desert, people will start thinking only about hot deserts. Hot deserts is the one which is there in climate chart also, I agree. But desert is a very large classification. Desert can be hot, desert can be cold also. Take that very deeply in your mind. Never think only about hot deserts. There are cold deserts in the world. This is the location. And last point, largest desert in the world is Antarctica. Largest desert in the world is Antarctica. Antarctica, there is literally no rainfall. Okay. Then you told Sahara and map reading. Notes edithu. Look at the notes again. Sahara is the largest hot desert in the world. Largest desert in the world is Antarctica. Is it clear? Always remember. Okay. Ladakh is a cold desert. Very good. Yes, yes, good. Ladakh is a cold desert because of height. Increase in altitude, reduction in temperature. Very tall. 3,500, 4,000 meters from the sea level. Very, very cold. Let's go to the desert map. Where is my equator can rest? I put it to rest. Next is my desert climate. Yeah, this is my map distribution. And this is my rainfall distribution. Take it one by one. First is the map segment. Okay. See again, please wait. First, I will teach you hot deserts. The hot deserts are given in black. You can see them. Last section of Australia. Think back to map reading class of Australia. Very dry place. Namibia, Botswana, Kalahari Desert. Remember, largest hot desert in the world, Sahara, Arabian Peninsula, Iran. Okay, Sahara deserts. And remember the countries Peru and Chile, Atacama Desert in South America, and finally US-Mexico border, Sonar and Mojave deserts. Basically, all of the names should be familiar to you. And of course, Thar Desert in India. Thar Desert is an exception. It's in India. We'll have a different orientation for that. So these are the areas of hot deserts. Cold deserts, I'll use blue color. We will see later. First, we'll deal with hot deserts. Cold deserts are present in two parts of the world alone. First, something which is easy for you to remember. Patagonia, right here. Patagonia is a cold desert. Is it clear? And coming to Asia, fine. Take Asia, you'll find Gobi Desert in northern part of China, Mongolia border. Just hold on. There was something important right here. Really sorry. Now coming to cold deserts. Patagonia is a cold desert which you would remember. Argentina. Moving to Eurasia, you have your Gobi deserts. Okay, and Taklamakan Desert. Taklamakan Deserts is in China and Turkmenistan border, this region. Is it clear? So these are areas of hot and cold deserts. Let's look at the climograph first. Okay. Climograph. You can clearly see equatorial climate everywhere there was rainfall. You go to desert, some feeble amount of rainfall, not even 1.5 inch. Look at the number right there. Is it clear? Very, very feeble. Rarely rainfall will come. One example they given for hot deserts and one example they taken from cold desert. There is a difference between hot and cold desert. We'll see that also. So now we need to discuss why deserts are present only in certain parts of the world. Because if you remember the map, all the deserts will be present on the western side. Western side, western side, western side, western side, western side. This is an exception. We'll see that western side. Why western side? That's what we'll try to understand. So for that, you need to take two things in your mind. This is why we learned our climate charts. Equator is over, no? Correct? First thing you need to know is, should have drawn it better. Wait. Equatorial climate. Let's draw this desert region bigger. This is my desert. Desert is invariably found on the western part of continents. Think back. Equatorial low pressure belts. Subtropical high pressure belt. Air rises from the equator and goes to subtropical high pressure belts. Correct? So at 30 degrees, there is subtropical high. 0 degrees here. Subtropical high at 30 degrees. Listen carefully. Adiabatic compression, adiabatic expansion, adiabatic compression will operate both differently. Okay, and that we will explain when it comes to diurnal range of temperature. First, I want you to understand something called as offshore and onshore winds. I will apply the concept here, that's all. Offshore wind, onshore wind. I'm drawing here. Offshore, onshore wind. Simple people. Coastal area. Listen. Land. Water. Only two possibilities are there. Either wind can move from water to land. This is one type. Onshore wind. Onshore. The winds are onshore. Second type, wind can move from land to water. Offshore. So if someone tells you, I experience onshore wind in my region or offshore wind in my region, you should be in a position to tell whether he'll be having rainfall or not. Simple logic. When winds move along an area, whatever is possible along the route, they start to collect as much as possible. It can be dust particles, it can be soil particles, it can be water vapor also. Think back. Wind is, first I'll take onshore wind. Wind is moving from water to land, correct? So when large scale permanent wind system moves over water, they'll collect large amount of water vapor and they move to land. In land area, let's say there is a small hill, small plateau. Yesterday we saw now, you just need to uplift air. You uplift air, cloud formation will be there, precipitation will be there. Very simple. See, onshore wind is there, blowing from water to land, take moisture, give it to land. Rainfall will come. No problem. Checkbox. Reverse condition. Wind is blowing from land to water. Look at the logic here. Water to land, I will take one bucket, collect water in land. So you collect water from sea. After that, pour it over land, rainfall will come. Other condition, you're moving from land to sea. Land, what will be there? Sand will be there. Here, there is no rainfall. No rainfall. Meaning makes sense. So always remember, onshore winds give rain, offshore winds do not give rain. Because onshore winds collect moisture from the sea. Tell me whether you're done. This one? Onshore, offshore? If you're done, use the word finished. We'll just apply it over there, that's all. Onshore will give you rainfall, offshore doesn't. Simple. Good, thanks for responses. Simple diagram. Yesterday I was breaking your head, high pressure, low pressure, Coriolis force. Now application will come. Listen, wind blows from high pressure to low pressure. Northern hemisphere, Coriolis force towards the right side, downward arrow, right side. This is my final trade wind direction. Is this clear? I'll draw the trade wind, high pressure to low pressure. Look at the diagram. Trade wind, trade wind, trade wind. I'm coming to the western part right now. You take the western part. You see that? Listen carefully. Look at the three arrows I've drawn. Wind blows from land to sea. Offshore trade winds. This one, this segment. Offshore, I'll write it here. This one. Offshore trade winds. That is why there is no rainfall in deserts. That's all. It's that simple. Trade winds blow from land to sea in the western part of continents, and that is why hot deserts are located in the western part of continents. Offshore trade winds. Look at the diagram. This green color one and the blue color one right there. Offshore trade winds. There is no rainfall. That is why you get deserts on the western side. Simple. See, climatic regions is the most simplest one. You get that? First concept correct, then it's too easy. Now I'd like to draw the map over Africa. Tell me whether you're ready. They're concentrated on western side due to offshore trade winds. Simple. Now you should get the grip. Oh, now that is the reason we are breaking our head over physics again. First 3 classes only is very difficult. You cross that, then everything is application. Yeah, 2 responses. Thank you. Now we'll draw it over Africa. Listen carefully. This is my African continent. Equatorial low pressure belts. Subtropical high pressure belts. Subtropical high pressure belts. Wind blows from high pressure to low pressure, deflected towards right and tried by Coriolis force. Is that trade? This is my trade wind. Because of offshore trade winds only, here you have Sahara deserts. Right now, southern hemisphere, this is the direction of my trade winds. See, in case you have to, I'll draw it for you. High pressure to low pressure, high pressure to low pressure. Right side, trade wind. Got it? high pressure to low pressure. Coriolis force in southern hemisphere, left side. This is resultant. Correct? Draw on the diagram here right now. This is the resultant. That is the resultant. Namib Desert. N-A-M-I-B. Nib in Namibia. Namib Desert. Diamonds. Remember? Nib in Namibia. Sahara Deserts, Namib Desert. That's all. You can draw this for any continent yourself. Got it? I'll give you a few more seconds. Then I'll add one more point. Why is Sahara the largest hot desert in the world? You need to understand that. Listen now. Listen, no problem. You can continue drawing, but listen. I'd like to add this point. Why Sahara is the largest hot desert in the world? See, normally what will happen is, if you draw this wind system, okay, eastern side of continent will experience either tropical monsoon or tropical marine climate. That's what, look at the climate chart here. This side, no, eastern side. Eastern box will be tropical marine climate because their trade winds will become onshore. Got the idea? All the regions here, you'll see that later. But Africa, that is northern part of Africa, is an exception because of divergence of landmass. Look at the diagram. I'll first draw the arrow. Listen carefully. Listen, later you can draw. Trade winds I will extend. Trade wind, trade wind, trade wind, trade wind, trade wind, trade wind. See, if there is no landmass here, then winds will blow from sea to land. Once you blow from sea to land, eastern part cannot be a desert, right? But eastern part is a desert exactly because of landmass here. Arabia will be there. Arabian Peninsula. Is it okay? So wind is not moving from sea to land right now. Wind is effectively moving from land to land. When you think Arabian Peninsula is over, no. After Arabian Peninsula, at least water is there. Arabian Peninsula will survive. After that, Iran will come. Iraq. Iran will come. So Iran is here. Arabia is here. So if you think about it effectively, wind moves from again land to land only. There is, see, you can tell me, sir, Persian Gulf is present. Red Sea is present. See, compared to the size of land mass, the water bodies, the surface area is very, very less. Red Sea, how much water you can think, to feed the entire area. So these two surface regions, even though they are water bodies, both Persian Gulf and Red Sea, the volume of water is extremely less to really make a noticeable change. That is why Sahara Desert, instead of concentrated only on the western side, extends from western side to eastern side because of location of Arabian Peninsula and Iran. So due to presence of these two land masses, wind effectively blows from land to land again. So Sahara extends from western side to eastern side. Okay. So I know you're drawing. If you're done, use the word finished. I'll go to why there is less cloud formation in deserts. We'll see that. And because of that, what character do you get? Yes, multiple responses. So now we're going to understand why desert regions have less number of clouds. Clouds, if you think about it, they're almost nil. Very rarely do you find. And for that, again, we are going to our wonderful tricellular meridional circulation. Equatorial region, there is high temperature. We add a pressure belt, low pressure belt. Air will rise. See what happens. Listen carefully. Air parcel. Air parcel is there. Air parcel is rising. Yesterday's class notes. First, adiabatic process. Air parcel rises, work is done. Once work is done, reduction in temperature, then automatically adiabatic expansion and cooling. Due to adiabatic expansion and cooling, cloud formation, cumulonimbus clouds. This is what we saw in equatorial climate, high rainfall. Okay. So once cloud formation happens, what happens? Rainfall is coming. Air parcel is there, going up. Rainfall. See rainfall now. Rainfall is over. Once rainfall is over, already moisture content of the air parcel will keep on declining. Now, already water is becoming less in equatorial region itself. After 0, air parcel will go. It will descend. Where? 30 degrees. Subtropical high pressure belt. Here there is no adiabatic expansion, adiabatic compression. You get the meaning? Hadley cell. See, air rises now, automatically cloud formation will happen. Once air is descending down, you're pressing it up, how will air rise? So due to adiabatic compression, cloud formation is absent. Meaning makes sense? Is it clear? So due to adiabatic compression, cloud formation is restricted. Simple, that's all. See, and this is one of the reasons for increasing dryness in deserts. Already, the air parcel will lose most of the water in equator. Only some water will be there. Think back to yesterday's discussion again, we saw that with increase in temperature, the ability of the air parcel to hold moisture content will increase. I drew 2 water bottles, one water bottle with 1000 ml capacity. With adiabatic compression, there is more and more heating. If more heating, the air parcel can hold even more water. So when it depresses, even some amount of water is there, it will come and take. Okay, that's why deserts are very, very dry. Even if water will be present in the atmosphere, okay, but the capacity is very high for them since they undergo heating. Okay, that's why deserts are extremely dry. Right? I'll give you a few more seconds and I'll flip over. Now we'll need to understand, since cloud formation is not there, deserts are going to experience one property, hot deserts. What property we'll see now? I'll give you a few more seconds, then I'll proceed further. Okay. Adiabatic compression, cloud formation is restricted. Due to heating, their capacity to hold water vapor will increase. So when they depress, whatever water is there, they'll collect. They won't give. Is it clear? So air will hold as much water as possible. Very, very dry condition. Everything is geography. Is it clear? We'll go now. Look at this one. I'll give you 2 places. One is Chennai. Chennai has clouds. Cloud. This is Riyadh, Mecca, any place. Cloud is not there. Daytime, nighttime. You're just going to compare. Okay. Daytime in deserts. Nighttime in Chennai. Nighttime in Chennai. One difference in both the diagrams is cloud is not there. This is cumulus cloud. Listen carefully. Clouds can actually moderate temperature really well, and you can see this in this diagram. During daytime, we know that Chennai does experience high amount of temperature, but clouds actually contribute to some help because due to presence of clouds, even if there is intense amount of insolation, there will be some amount of radiation which is reflected back. Think back to albedo. Clouds are white in color. Okay, so because of this, a good percentage is reflected back, albedo. Due to albedo, even if heating is present, temperature can go up to 40 degrees Celsius, 42 degrees Celsius. Good. Same condition, you come to a desert region, there is no clouds at all. Intense heating. No one to block. That is why the daytime temperature in deserts is very, very high. It can go to 55 degrees, 60 degrees Celsius in a desert. Very, very hot. Right? Let's come to the night time. People listen. After they heat the surface, incoming solar radiation, they'll be re-radiated back. This we already studied. Now the gases which are re-radiated will be blocked by the clouds. You'll ask me, sir, how can clouds block? Think again. Clouds are made of water vapor, and water vapor is an excellent greenhouse gas. See, even if sunlight is not present during daytime, the re-radiated radiation will be blocked by the clouds due to greenhouse effects. So radiation trapping by water vapor. This is what we studied as greenhouse effects, GHE. Okay, so what will happen is temperature doesn't fall very, very low. Even if sunlight is absent, temperature will be possibly 25 degrees Celsius. Okay, not very cold. Come to desert right now, you can receive 55 degrees Celsius. But since no clouds are there, no water vapor is there, which is the most important greenhouse gas, all the energy will leave the system. Once it leaves the system, temperature will be very cold. It can go to 0 degrees times minus 5 degrees also. This is in a hot desert, people. Understand, the desert might be hot, but within the hot desert, during the night time, the temperature will be very, very cold. And this is an important character of hot deserts, high diurnal range of temperature. High diurnal range of temperature. Diurnal, I think you remember the meaning. Diurnal means high variation between daytime and nighttime temperature. Character of hot deserts. So don't get confused between hot and cold deserts. High diurnal range of temperature in hot deserts because absence of clouds. Once you've taken on, use the word finished, we need to look at one type of temperature inversion. All the concepts just recollecting. Temperature inversion. With basics, it will be simple. One response. Very. Yeah, thank you. See, this type of temperature inversion is observed in deserts not every day. Happens during winter season. Why do I specify winter? Reason is, compared to your summer, during winter, the temperature will be even lower. Is it clear? So you might automatically ask me, sir, where does the water come? That's why initially itself told you, water is present, but the capacity to hold moisture is very, very high for air parcels, right? So you take a specific condition, not always, but specifically, long, calm winter nights. So clearly told you, not always, very rarely. People from Haryana, Punjab would know. They would experience fog. Okay, Delhi would know. They would experience fog. Rajasthan would know. They would experience fog. People from Dharmaburi, Krishnagiri in Tamil Nadu, they will know. Winter season, there will be fog. Even though it is dry land area. How does it happen? Simple concepts. Surface temperature influences air temperature. That's all. One single principle. Entire climatology over. This is the surface. Okay. Radiation, you know, all the radiation will be is getting released from the surface during night time because clouds are not there. Just now we saw. I'm taking two different layers of air. Listen, every batch when I explain this, they get out. Surface that I've drawn in line. Above the surface, there will be an air layer. This air layer is in proper contacts. So air layer with proper contacts. Possibly 200 meters thickness. Okay, proper contact with the ground is there. Settling over. Maybe take 100-meter thickness, just 100 meters. Proper contact is there. Above that, one more air layer, not proper contact with ground. No contact with ground. With ground. Now, normally, energy is getting radiated outside. After that, let's say temperature becomes 0 degrees Celsius. 0 degrees, 0 degrees. Is it clear? This is air's surface temperature. 11 p.m., 12 a.m., 1 a.m. Slowly surface will radiate heat as much as possible. So surface temperature, let's say it becomes even more colder. -5, -10, -5 degrees. Very, very cold. So 1 a.m. in the morning, 2 a.m., 3 a.m. As slowly time progresses, surface temperature influences air temperature. You got the meaning? What will happen is the layer which is in contact, slowly after coming in touch with the surface, it will become even more colder. You got it? Let's say from 0, it changes to this 0 will remain the same. Why it is same? Because it's not in proper contact. So its height, 200 meters height it is there. Surface is not influencing. This is still at 0 degrees Celsius. But due to surface cooling, surface cooling, this would become -2. See, I'm taking -2 as arbitrary. Okay, or you want see, -5 in the sense it cannot become -5. It's not simply possible to transfer all the energy. Thing is, it will cool it down. Got it? So around 3:30 a.m., 4 a.m. in the morning, and all the heat is radiated out and air is cooled from below. Look what happens. Increase in altitude, there is increase in temperature. Don't ask me how. You're going from -2 to 0. Is it clear? Now let me explain fog formation in deserts. Assume there is an air parcel whose dew point temperature is -1 or -2 degrees Celsius. Now, dew point temperature will be reached exactly at the surface itself. So if you find dust particles, aerosols, cloud formation will start here itself. Clouds at ground level is nothing but fog. That's all. Is it clear? So this type of temperature inversion is called radiation temperature inversion. Happens in deserts during long, calm winter nights. Why is the word calm? Because only then air will settle over and you get that surface influence. Good enough. Radiation temperature inversion. So 3 types have introduced temperature inversion. First is stratosphere. Second is upper atmospheric, ionosphere. Third is radiation. One more we'll see during cyclones. Wait for that, okay? So all this was the reference to hot deserts, characters. Now we're going to cold deserts right now. Cold deserts, again you need to draw diagrams. The only problem is, like if you were here, I would know how fast you're drawing. That's the only thing. Now I need to get response from you. Only then I'm moving up. So tell me whether you're done. That's all. Okay. Raj, I'll come again for fog later. Is it clear? Like just like yesterday, we'll have the doubt session at the last. That time we'll discuss that. No problem. Just take this down. That's it. Next, we'll proceed further to cold deserts. Again, I know that human geography is not done. We'll finish this. Please wait. Cold deserts. See, 2 regions of cold deserts. Both of them have different reasons. First, we look at Patagonia. Simpler reason. Okay, first, cold desert formation. Patagonia. Very simple. And for explaining Patagonia, I need to teach you one concept called orographic rainfall. There's a second type of rainfall. Orographic. See, this is a totally different topic. I'm teaching this so that it will be easy for you to understand cold deserts. Orographic rainfall. And later, what people will ask me, sir, will orographic rainfall happen only here? Second type of precipitation. First one is first type we just saw right now. Convectional rainfall. Surface heating, air rises, cloud formation, rain. It is second type orographic. Orography is related to mountains or plateaus, mountain formation. So due to presence of mountain, how do you experience rain? Very simple. Picture an air or wind system which is moving very fast towards the mountain. See, it's very simple. Mountain blocks this area. It is impossible for air to escape out. It will be forcibly moved up. Don't ask the question one vast years. Don't say that. It's not. Mountain will be extending for several hundred meters and kilometers. They can't do like that. They'll be forced to rise up. In one side of the mountain where air passes move up, they are forced to do work. Mountain says you go up, work fast. So work is done. Adiabatic expansion and cooling. Adiabatic expansion and cooling. Cloud formation. Rainfall. So there is high amount of rainfall here. Rainfall. This is called as windward side. windward side. Now, all the moisture will go descending down. Other side, no rainfall. No rainfall. This is my leeward side. Leeward side. As the wind begins to move down, there is an interesting phenomenon, adiabatic compression. How adiabatic compression? Simple, see what happens to pressure. This is the pressure on top of the mountain. As the wind slowly comes down, look what is happening to atmospheric weight right here. Slowly more and more weight is getting added. Adiabatic compression. Okay, so adiabatic compression. So all these things I've drawn is the atmospheric pressure at mountain, atmospheric pressure at ground level. Slowly pressure is increasing. Compression, it will lead to heating. Heating. The final wind is there, no, this wind. Last person who's coming is a very warm and dry wind. Warm and dry wind. That's why leeward side is not an ideal condition for you in most of the activities. Warm, dry wind will descend down the mountain. So windward side, leeward side. Adiabatic expansion, rainfall. Adiabatic compression, no rainfall. Okay. Expansion, compression. This concept will simply apply to Patagonia. That's all. I know that I'm making you draw diagrams, but that is the essence of geography, isn't it? You're done, just said tell me yes, that's all. I know that's wrong to force you to chat, but this will apply for Marwar region of Rajasthan also. Marwar won't work because Rajasthan is actually parallel to mountains. That is the reason Rajasthan is a desert. Like, you can know it now itself. Anyway, you'll have it in India. See, if mountains are present like this and wind systems come here, mountains will force the wind system to move up. You take Rajasthan. Rajasthan is a different desert. That's why it didn't teach you Rajasthan. Rajasthan, if wind systems are coming like this, mountains will be standing like this. Okay, you get, wind is coming now, I should catch you and lift you up. Rajasthan, the mountain will be standing like this. You run, a mountain will say, go. Wind will go. If wind goes, where will rain come? Rajasthan, you don't experience orographic rainfall. It is not on the leeward side. So what happens when both sides of mountain gets winds from mountain? Who are you, man? Who are you? SAAN 2066057. How do you get these type of questions? I really don't know. What will happen when both sides of the mountain gets winds from both sides? It will rise, man. Cloud formation will happen here. It's clear. How? I don't know. Where do you get these type of questions? Geographically, I don't know, man. I've been studying for some time, quite some time, not long time, but quite some time. As far as I'm concerned, I've never come across this doubt. I don't know geographically any place on earth where that happens. Is it clear? Hypothetical person. Orographic rainfall is not similar to rain shadow concept. Raj, orographic rainfall is rain shadow. This is the rain shadow region. Leeward side is your rain shadow region. That's one more name, that's all. Okay, windward, leeward or rain shadow, just another name. Now we'll come to South America, Patagonia. It's more like there is, I don't know, non-Tamil speakers wouldn't understand, but in Tamil there is a word, there is a comedy. It says, Enna paatha andha kelvi keta. I feel like that right now. The person who asked a question, what will happen if winds come from both sides? Enna paathu, how you can ask means, how can you ask a question to me for non-Tamil speakers? Is it clear? See, this is my Andes mountains. I'm going to draw two pressure belts. Equatorial low pressure, subtropical high pressure. Look at the beauty right here. You find hot deserts and cold deserts because of peculiar Andes mountains. Andes mountains doesn't play a role for one, but it plays a role for another. See, I'll draw wind direction for both. First direction will fill here itself. Wait, let me finish this one. Equatorial low pressure, subtropical high pressure. Subpolar low pressure will be quite far away. 60. See here. Wind blows from high to low, high to low. Coriolis force in southern hemisphere, left side, resultant, trade wind. Left side, resultant westerlies. Correct? Resultant is there. This is something I taught you already. Wind blows from land to sea. If this is a hot desert, this is a hot desert, Atacama. Hot desert, Atacama. Atacama. Chile, Peru border. Clear, no? Now we'll come to cold desert. This is new for you. Listen here, then you can draw. New one. This resultant. This one. This may resultant. Clear. See, now mountain is there. Don't ask me how it happens. Mountain is present. Andes mountains is present. Wind is moving in this direction. So if rainfall comes, rainfall will be present on the western side of mountains. Look at the same diagram I drawn previously. Look what happens. Wind comes, rainfall will be there on the western side. Once they go to the eastern side, no? This is dry land. Got it? This is my Patagonia deserts. Patagonia is a cold desert. Cold desert. Okay. Because it is on the leeward side. Leeward side of Andes mountains. That's all. Leeward side of Andes mountains. That's offshore trade. This is normal case. We already saw this. Offshore trade. Okay. Got it. So Patagonia is straightforward. It's the leeward side of Andes. Right? What happens when both side of mountain gets winds towards the mountain? I should unmute and talk to you, man. Where do you get this doubt in Suli? Wait. I'll do it. Today I'll do it. 66057. Tell me whether you're done. One response. Yeah, thank you. See, second desert is a question of distance, that's all. We look at Gobi Desert now. Gobi coming up. So, Mediterranean Sea, Red Sea, Arabia, India, Malay Peninsula, Sumatra, Indochina, China. This is Gobi Desert. Right there. See, please note, Gobi is a desert because it is very far away from any water source. There are two water sources here. For example, Mediterranean Sea. This one, Mediterranean Sea. You get Caspian Sea right here. Mediterranean. In case you have the map, it's much easier for you. This is Caspian Sea, right? So you take the wind system. Winds are moving in this direction. Look at it. Below there is trade winds. Here there is westerlies. So the point is, do westerlies collect moisture from Mediterranean and Caspian Sea? Simple answer is, they take moisture. Problem is, look at the distance right there. Distance is high. Since the distance is quite high, by the time the winds reach here, no, most of the moisture they lose in the center itself. It's like this. You take bucket, fill bucket with complete water, stand here, put one hole in the bucket. Water will start falling, rainfall will come. Keep on walking to the other areas, look at bucket, bucket water won't be there. That is why Gobi there is no rainfall. Gobi is a desert because it is very far away from the water source. Gobi is, not Gobi's. Gobi is very far away from water source. Now, immediately one more question should rise. So, why are you talking about Gobi deserts? Don't we have one more desert in Turkmenistan-China border? Yes, we do have. And the reason for the Turkmenistan desert is again rain shadow concepts. Air will rise and again there is rain shadow region. That is why you'll have a localized region. Mountain will block. Okay, this is distance. Okay. Because if you look at the map, you'll understand, no, Caspian Sea and the area is very, very close by. How does this area have a desert? Mountains will be present. If physical map is there, you can look at it. Okay. That's the reason Gobi is a desert. There is one more character of cold deserts, after which I can talk about human geography here also. So all rain shadow regions are deserts. Raj, all rain shadow regions are either deserts or semi-arid region. Semi-arid means the rainfall won't be as low as 2025. You take central Tamil Nadu. Central Tamil Nadu is a simple example. Dharmaburi region, Krishnagiri region, Salem region, you take the entire belts. That's on the leeward side, no? Leeward side of Western Ghats Mountains. Their average rainfall is only between 50 to 60 centimeters. Okay, those are semi-arid regions. If a desert is there, semi-arid region is there, rainfall is less, there are very good chance it will be on the leeward side. Okay. It's either arid. Arid is a desert, semi-arid, slightly higher rainfall. Technically, entire central region of India, like you'll see it in Indian geography, starting from Punjab, Haryana, Delhi, western part of Uttar Pradesh, central Madhya Pradesh, eastern Maharashtra, Telangana, southern Karnataka, northern Tamil Nadu. Full belt of India, the entire region rainfall will be less. Okay. Oasis formation, I'll explain, no problem. Pune is not a desert. No. Pune is not. See, Pune is there in the rain shadow region, but it's very close to the mountain, no? See, and monsoon brings so much of rain. So much of rain. See, one side will be 200 centimeters and 250 centimeters in Mumbai. Just cross over Pune is there. After Pune, you go several regions only. Eastern Maharashtra, Vidarbha will come. Vidarbha is a dry land. Telangana is dry land. Telangana quite far away. Okay. So oasis we will see, no problem. So now to one important character of cold desert. I've already showed you this, but still recollecting. Hold on. Let me show you the climograph. See, hot desert climograph, if you see, there won't be any there will be variation, of course. You're moving away from equator, not a larger variation. Larger variation will be found for your cold desert climograph. Look at it right now. You clearly see that. Summer season is very hot, but winter season is very cold. This is what I told you, relation between latitude and temperature. With increase in latitude, annual range of temperature will increase. We finished this already. Okay. So please note, cold deserts, annual range will be high. Hot deserts, diurnal range will be high. There is a difference. Hot deserts, diurnal range. Cold deserts, high annual range. High diurnal range hot deserts, high annual range for cold deserts. Any doubt is there, look back to notes, relation between latitude and temperature, right? Go to the next point. Natural vegetation, we never got to talk about that. Natural vegetation. See, here it's very easy to guess. Domination of thorn forest. Thorn forest. In many cases, plants will be absent also. Some areas, there won't be any plants at all. Total absence, both are possible. Water is not there. You might have high temperature helping photosynthesis. Without water, it doesn't work. So the most important species which you can easily understand is cactus. Right? So we'll just compare with a normal plant. Yeah, and we'll try to understand what are the basic differences which has been done right here. See, first, let's take the leaf concepts. Why do you have leaf? And because for photosynthesis. Why do you need photosynthesis and why does the leaf spreading over? Only if you spread the area to a very large extent, you'll be able to receive as much sunlight as possible. This is acceptable in an area where there is large number of water resources. But here is water is absent. If water is absent, you cannot lose water. If you show your area, there is more and more leaf surface area. Water will leave the system through transpiration, stomata. So water will leave the system through transpiration. This is acceptable in a humid condition because they have access to water. Here, no water. So first modification is leaves are absent, they are converted to thorns. Leaves are absent, they are converted to thorns. Number two, you take your stem will mostly be in brown color or dark color. Is it clear? Because they don't perform the function of photosynthesis. If I'm going to convert my leaves to thorns, my stem will need to perform photosynthesis, right? So that is why stems are green in color. Stems become green in color because they need to perform more and more photosynthesis. Number 2. Got it? This is brown. This itself will be green. Talking about the nature of stem, the purpose of stem in a humid angiosperm condition is that it needs to provide proper support to the plant. So very woody and very strong, woody structure. Here stems are not woody, they are succulents. They store more water. Succulent stems. I need to store water. Water storage. Got it? Fourth adaptation, compared to my conventional plant root system, the root system is very, very extensive, searching water everywhere. Extensive root system. Extensive root system. That's number 4. And last one, important character of these things is, most of the desert plants will have waxy coating. Will secretes wax. Why exactly? Simple. Think about albedo again. If there is more wax coating, sunlight comes, more reflection. More reflection, then plant won't get heated. They don't want to lose water. Recollect again. Broader surface area, more stomata, water will leave the system by transpiration. To control transpiration, convert them to thorns. Number 2. Usually stems are brown in color. You convert them to green color because you want to perform photosynthesis. Leaves are not there. Number 3, they are hard for supporting the structure. Here, support is not the major reason. You want to store water. So stems become more fleshy and more succulents. They're much fleshy. Number 4, compared to humid conditions, water is scarce, so root system is very extensive. And to prevent increase in temperature and to store water, the plants have better waxy coating. So more waxy coating, more reflection of your sunlight. That's how they conserve water. I think comparison will give you an immediate idea. That's how it works. Okay, we'll go to human geography now if you're ready. So this is the major thing. Any part of the world, the species will change, but the adaptation is the same. 5 major ones. So now human geography will give you a complete overview on what exactly is happening in this place. Yes, thanks for the responses. I'll move to human geography. Economic development part. Economic development. Because I'll write this as the heading. I wrote human geography, one person couldn't find it properly. First, we look at traditional mindset. Traditionally, ma'am, Oasis I will explain post the break. Okay, if I have time, I'll explain ourselves. First, I want to provide importance to this. First one, generally, normally means it's applicable to contemporary world also. Desert climate, this is the most important activity. People lead a nomadic lifestyle only. I think meaning of the word nomad tells you something. They don't settle in a same place over a period of time because water is scarce. Only in certain regions water will be present, and once they start using, water gets exhausted. So they constantly need to keep moving in terms of both water. That's the major resource. So they don't settle in one place. It's mostly semi-permanent settlement or nomadic settlement only. Constant movement will be there. So constant movement through which one? The usual herd is camel herd. They'll have their own camels, and it's a very important resource in the deserts, and they need to fetch water for camels too. So very large distances they keep on moving. And there are important tribes in different parts of the world which are known for their nomadic lifestyle. I'll just note a few of them. So you take the Bedouins of Arabia. Okay, you take the Aboriginals of Australia. Okay, or the just not able to get the name in the Kalahari deserts. Kalahari don't exactly remember the name of the tribe. Kalahari, there is one more famous tribe. Can anyone help me out? Kalahari? Not pygmies. No. Kalahari? I don't remember. It just doesn't strike me. Conventional things, you know a lot of things, but okay, fine. Like Kalahari, there is an important tribe again. San people, okay. Might be given in the text. But anyway, I'll come back on this. If it's already there in the book, you take it out, okay? So Kalahari is one more important place known for tribes. So these are major tribes of the world which you should know. Now, what we're going to appreciate and understand is how has human geography changed in this area from nomadic lifestyle? What has led to variation in different parts of the world? So traditionally, this is not a climate. Bushmen, Bushmen or San people, correct. San or Bushmen. Take this, let me explain the population and demography. San or Bushmen. Bushmen of Kalahari, right? Bushmen. Now I think we'll come to population. People traditionally, population is less. Population density is less. You don't have economic development in large scale also. Highly restricted. That is why you go to your early part of 20th century, you wouldn't find Saudi Arabia, United Arab Emirates being very, very dominant countries. But later, as time progressed only, they found that deserts are a gold mine. Not literally in some places it is a gold mine. Now, currently, deserts economic development is not governed by the climatic aspect, but the non-climatic aspect, especially what mineral is present in the desert. Different parts of the world have different access to minerals. I just write them out for you. So mining is the major economic activity, and what you mine is different in different parts of the world. For example, diamonds. So this is Kalahari Desert. Kalahari, Namib Desert. Botswana, Namibia. Just linking with your map reading notes. Botswana, Namibia. Please note, Kalahari Desert is not spilling over only to these countries. It spills over to metals and diamonds again. I think you understand the country. Same region, South Africa. South Africa. Again, I told you one country is the big daddy of mining industry. Again, think back. Australia, metals, non-metals, right? Heavy metals, fossil fuels, all of them. So uranium is present, coal is present, Australia. Very important mining country. Then you have Arabia. All the Arabian countries, Arabian Peninsula, oil and natural gas. Any Arabia and Iran. Arabia, Iran. Got it? You think it ends here, but not. Again, it's there in map reading. Think about this one. Chile and Peru, Atacama Desert. Atacama Deserts. Sorry, I write the what we are exporting first. So metals again. Metals, you would think about your copper. Chile is the #1 producer of copper in the world. You go to Peru, copper, lead and zinc. Think back, again there in your notes. Copper, lead, zinc. Both ore and finished metal. Countries Chile and Peru. Chile, Peru. Atacama Desert. Okay, so it's not related to climatic region. It's like this. You don't have opportunities for agriculture, then you try to explore different other opportunities. There's no other way. If water is there, people will simply say, okay, we'll do agriculture, we'll do fishing, that's it. No, but just not that. You try to improvise and move to the other ones also. So that is why this is a non-climatic factor. The presence of minerals has completely changed the dynamics of all your desert climatic regions. But if you think carefully, there'll be certain parts in the world which I have not mentioned. We are talking about regions in Asia. Okay, it is true that Central Asian countries you can fit in here itself. Central Asia, if you think back, I would have said metals and metals. For example, Turkmenistan. But Central Asia, I will come back. Like for example, I'm talking about Eastern Asia, Mongolia. Mongolia, you have copper, Gobi, metal, copper. Gobi deserts, yeah, Mongolia. Large part of Central Asia will come under steppe climate. That's where the Turkmenistan desert I'm not providing more importance, because large, when we go to steppe climate, we'll see that all the five of the Central Asian nations. So these are my industries, and we need to appreciate one fact here. It may miss your eye. See, when we usually think about water problems, problems due to climate change, you always get the idea of glaciers melting, ice caps melting. One of the climatic regions which is severely affected by climate change is actually desert regions. The reason being, deserts really do not have much water. If population density increases, for example, let's take Arabia, you take Dubai in United Arab Emirates or Abu Dhabi, or the increase in population in Riyadh or Muscat, you're not supposed to have such large cities in these places because they really don't have that much water. So this creates water problems not just for people who are part of these cities, but it puts strain on the conventional water resources in this area. The entire ecosystem will be affected if humans keep on exploiting water for other resources. So climate change, especially related to water problems, is severe in deserts because population is increasing due to mining. Meaning makes sense. Due to mining, there is increase in population, there is increase in prosperity also, and that is placing high demand and high problems on water exploitation. Basically, so that's an environmental problem in desert climates. So non-climatic economic development, all parts of the world. I think now you get the link. You don't find agriculture, you go to the other one. Okay. Mongolia has uranium also. I think you're right, ma'am. I'll get back. I don't exactly remember. The reason it doesn't strike me is it's not a major player where countries go to sign agreements. That's why it will, because copper is present again, not a major player. The governance issue. That's all. If you want to exploit it, it should be proper government. So this is the last point. Shall we proceed further? Creation of cold deserts. But why cold deserts are cold? Is it because of altitude? Raj, cold deserts are cold because of latitude. Think back. Both Gobi deserts and Patagonia desert is located at 45 degree, 50 degree north, 45 degrees south. You move away from the sun, naturally average temperature will decline. Ladakh is a cold desert because of altitude. Patagonia and Gobi, latitude is the reason. Okay. So this is the last point. Oasis, we'll do it when we come back again. Shall I proceed further? Okay, fine. So you finished two climatic regions, but I think this itself would give you an idea how climatic regions will progress. It gives you a proper connect with relation with current affairs also. Always remember, the second part is your main part. This one, the human development, and so please don't think that a human geography was not handled. We are actually handling it. And distribution of industries. Think back to your syllabus again. Location of primary, secondary, and tertiary industries will be from here only. Fine. So take a break for 30 minutes, whatever be the time in your watch. I'm finishing 3 minutes early. Okay. 30 minutes break. When we come back, I'll start Oasis just few 2 or 3 minutes. Let's finish that. And then let's go to two more climatic regions, British Mediterranean. Then I'll give you a lesson plan. We'll possibly start with or finish one cyclonic system today. Okay. Take a break, 30 minutes. So 2 climatic regions are done. 2 more are present. One is British. Okay. Post-British, we'll be looking at Mediterranean climate. After British and Mediterranean, we'll step into cyclonic systems. And today I will tell you about tropical cyclonic systems. There are again 2 types are there. Tropical and temperate. Again, it won't be possible for us to finish today. But once we finish at least the tropical cyclonic system, I think we will cover quite a larger section of climatology. Then after that, we'll be having, I'm talking about next weekend. It'll be really good if I get class again. Next weekend, air masses, extratropical cyclones. We finish that, then we can compare jet streams and remaining climatic regions. So next weekend, if we get the chance, I think try our level best to close out climate. Bigger chunk of world geography will be over. Geomorphology 2 sessions, oceans 2 sessions. Then you need 1 more weekend, geography is done. I mean, world geography is done, not Indian geography. Okay, so today's lesson plan, the remaining 2.5 hours, British climate, Mediterranean climate, and finally, 1 type, tropical cyclonic systems. Is it okay? Let's start now. So let me address this word, like how does oasis form? Oasis primarily form due to deflation. Deflation simply means a blowing action of the wind. Blowing, wind action. So it happens where you have several layers of sand. So please note, desert region you take 100%, sand concentration will be very less. But we have the mindset that the entire desert is made of sand, isn't it? That's not true. 65 to 70% of the desert will be normal plain land, as you see, as you walk on the road. So thing is, certain areas you'll have some loose soil, which can be easily eroded. So the deflation action of the wind will be able to force and take out that soil, which can be easily eroded. So this creates a depression. We call them deflation hollows, depressions. Now in this deflation hollow, over a very long time, groundwater can collect, okay? Because it's moving to lower and lower levels, groundwater can collect. So once groundwater collects, this will be your oasis. Point to be noted, water collection in oasis can take more than a year. Very slow process, even several years. But once human beings come here, I told you, nomadic herding, moving from one place to another, they might come to oasis, they might stay here. It will get exhausted in 1 to 1.5 months because our usage will be more than actual water present. Then they'll need to leave again. Then again the oasis will recharge. The location will be same. Got it? So in deserts, near the oasis alone, you'll find more concentration of plants. This is a paradise. Paradise in hell. Okay. Now let's go to the next climatic region. British climatic region. So this is quite simpler now. Equatorial, done. Deserts, done. We're going further north. I'm leaving this box, I'll tell you later, not this one. Further north, quite colder place, British climate. Cool temperate western margin. I think it'll be there in your, I don't remember the chapter number, but you can look at the index. Cool temperate western margin climate, called as British climate. Okay. So what exactly is, or how exactly can we define British climate? We'll start with the map again. Hold on. First map and climograph. So my deserts are done. Goodbye deserts. There is my, British. There it is. Okay. I think you see the areas clearly. So the name Britain is given because this is the climate which is experienced in the island of Great Britain. That is taken as a proper representative. So large sections of Britain, first the British Isles. After British Isles, western part of France. Think back again, Benelux countries, Belgium, Netherlands, Luxembourg, and then Denmark, right? Not all Scandinavian nations. You find Denmark and then Sweden. Sorry, Norway. Just Norway. Then again, not entire Spain and Portugal, northern part of Spain and Portugal. I'll repeat again. Great Britain, let me zoom in for you then. Yeah, I think this is much better. Look at it again. Great Britain, most parts of France, that is northern and western part of France, Benelux countries, Belgium, Netherlands, Luxembourg, Denmark, Norway, northern part of Spain and Portugal. So again, this is a split concept. You move further, come to the western region. Again, you clearly see that it's mostly Canada, western part of Canada, very narrow corridor. Come south, Chile. Okay, southern Chile, not northern Chile, again southern Chile, and including this small archipelago of islands. You come to southeastern side, parts of New Zealand and Tasmania, the island of Tasmania in Australia, the small island. So if you look in terms of surface area, British climate is very less. Okay, certain climatic region, deserts area was very high, smaller areas. Okay, so what is a major character of British climate? Well, let's start with the climograph now. You clearly see, similar to equatorial climate, here also you'll find one similarity. I'll zoom in. Similarity is this. Rainfall is present throughout the year. Surprise. So first we need to investigate what makes British climate, which does not experience very high temperature, have rainfall throughout the year. Let's go back to the climograph. After we understand the reason. Simple, people. Even. Okay. This was my desert climate. Deserts, this is my British climate. Correct? Subtropical high pressure belts, this region. Listen, deserts are present because of this reason. Offshore trade winds, right? North of trade winds, you have your westerlies. Correct? Now, let me draw the direction of westerlies. You'll be in a position to understand. Look carefully. This is my westerlies. You see that? North of trade winds, westerlies are present. These winds are onshore westerlies. And onshore westerlies provide rainfall throughout the year. They are under the permanent influence of westerlies. That's all. Doesn't matter whether it's January, doesn't matter whether it's December, you'll find consistency in rainfall. There will be variation. Of course, summer rainfall is definitely more, winter is colder, but westerlies are present throughout the year. And this is something you should always remember. If wind systems come to land, simply because of onshore winds, you won't get rainfall. Wind systems will move towards land. Land should have some elevations. See, the elevated region can be as short as 300 meters, 500 meters, it doesn't matter. Only if a mountain or plateau or any upliftment structure is there, the wind system will be slowly moved over, clouds will form, rainfall. Why am I insisting that? Because you should understand difference with equatorial climate. Listen here, two differences are there. Because equator also we saw rainfall throughout the year. We should appreciate the differences. The differences are these. First one, the rainfall between British climate and equatorial climate varies in terms of quantum. Equatorial climate, rainfall in equatorial climate is much higher than rainfall in British climate. Take the average, equator it was pouring down, right? Not the same case in Britain. Number two is the nature of rainfall. Equatorial rainfall is heavy downpour, torrential, very big water droplets. They just hit your face, hit your ground. But you take British climate is nice, soothing rain. Okay. More drizzling and soothing rain. Okay, like rarely only you form very heavy clouds. Is it clear? So these are two differences with equatorial climate. Onshore westerlies. So rainfall is throughout the year. Wind blows from sea to land. Got it? That's why it is again found on the western side of the north. Chapter 22 is British. Thank you. So equatorial, heavy downpours. British, more of light drizzling rainfall. Got the idea? So that tells you about both my temperature and rainfall. Tell me, are they ready for natural vegetation? We'll see which forest is dominant. You know, as time progresses, connecting each climate will become very, very simple. One response. Yeah, thank you. Multiple responses. Now, to appreciate natural vegetation, we'll go to climograph and look at the temperature problem. Like this is what we finished, rainfall. Look at temperature right now. Again, increase in range of temperature, right? So summer season, you see a perfect bump, increase in temperature. Winter season, there is a perfect down. So with increase in with increase in latitude, annual range of temperature increases. Conventional relationship with latitude and temperature. Repeat again, increase in latitude, increase in annual range of temperature. No doubts because it's moving away. Now, what you will need to understand is this will play a major role in natural vegetation. If you think back, during summer season, there is a marked increase in temperature. As the latitude is higher, during winter season, with low viewpoint temperature, you will get very good snowfall. Is it not? Now, if you look at natural vegetation, the natural vegetation should be in a condition to adapt to both these climates. So, natural vegetation, the dominance is with reference to deciduous forests. Deciduous forest. Why deciduous forest? Because there is a marked noticeable change. Marked and noticeable change in both summer and winter season. Hence, plants adapt. Plants adapt by shedding leaves in autumn. Plants adapt by shedding leaves in autumn. So summer season is there. This is the point I used for explaining the order of seasons to you when we discussed it quite some time back. So there is a proper summer, there is a proper winter. Plants will need to shed their leaves for facing winter season, right? So something which you've already seen earlier. Okay. There is a marked noticeable change in both summer and winter season. So here plants adapt by shedding leaves in autumn. So proper segregation, proper markage of seasons will be there. So since shedding of leaves is dominant, areas where shedding is found, that is where you have your deciduous forests. That's the relationship. Deciduous forests shed their leaves during autumn, right? Just hold on. Let's see whether we have an access. Just hold. See, the audio is not required. I'm just concerned about the video segment. I've switched off the audio myself. Just want you to understand. How things change. Fine. So first, he'll be starting with the late summer season. Let me go to the sunlight time. Okay, so starting from late summer, so you see that the plants have leaves, the trees have leaves. Over a period of time, the leaves has been shed. Most of the plants are naked right now. You see that? Autumn. Fine. They go to autumn because they need to adapt for winter. Only if they shed their leaves. You can clearly see it. All of them shed their leaves. Fast forward, you get winter. Snowfall. Thanks to the person who was very patient for more than a year. Show this video. Same location. Winter. So now I think it makes more sense. You don't want your leaves to experience frost action. You don't want snowfall to accumulate on your plant. So you were ready already. Deciduous forest. Proceed further. Over a period of time, the snow is going to melt away as temperatures rise, right? And then when the snow gradually melts, look at the same trees again. They'll re-blossom back. This is spring. Look at this tree right here. How will it change? Okay, you can clearly see that the trees become much denser, right here. It's as if it was non-existent few months back and then it has sprung to life. This is spring. And post-spring, summer and the entire cycle will get repeated. Is it clear? So that's your deciduous forest, where you can clearly see noticeable change of plants adapting to climatic conditions. Okay. Now, fine. Now, proceeding further, you need to understand that large parts of natural vegetation in all these regions has been decimated. Now, why did they destroy forests? You know the answer already. Think back to the countries which I told you. Most of them are highly urban nations. So, thing is, during the process of industrialization, you can leave Chile out. Chile, you do have a large area which is forest. Same can be said for New Zealand and your Tasmanian island of Australia also. But you go to Europe, that is northwestern part of Europe, where we discussed this climatic region, there most of the deciduous forest area has been cleared and has been completely industrialized. Now talking about human geography, economic development. Okay, hold on. Right, I think this should be fine. Going to human geography and economic development, we will understand that it's not really governed by climate factor, but something else. Not really climate, but non-climatic factor. The major activity is market gardening. Market gardening, also called as mixed farming, dairy farming, mixed again, dairy farming. So clarity on what these two things are. Market gardening is the cultivation of your horticulture, your fruits, flowers and vegetables. Talking about your dairy farming, milk and milk products. Milk and milk products. So let's hit the ground running. See, why do you have something called as cultivation of more fruits and flowers and more milk products? Does it mean that the other climatic regions can't produce flowers? Not true. Flowers grow well in India also. Fruits grow well in India also. We are in monsoon climate. Now, why do we say that this is the most relatable economic activity in terms of rainfall? The answer lies in the nature of the region, high urban population. That is the relationship. High urban population. Due to high density of urban population, think about the first thing which you eat every day morning. I should rather say drink. Milk, isn't it? You either have milk, tea or coffee. At the same time, you take your other demand, there'll be constant demand for fruits and vegetables in the area because that is something which is highly perishable. So if you want to produce your fruits and vegetables, you make sure that you cultivate the commodities very close to the region. Think back to the urban density population again. Let me recollect some regions of urban setup for you. Belgium, Netherlands, Luxembourg. Think back to Amsterdam, Paris, London. Look at the amount of urban population which you have. The population density is extremely high in this region and highly urbanized. So that creates consistent demand for both fruits and vegetables, flowers at the same time, milk and milk products. The answer lies in high urban population, high population density also. Population density is very high in these regions. See, I'm talking Western Europe. That's the largest set. Western Europe. And that is where you find market gardening and dairy farming. This is not true for other regions. For example, you take British climate in Canada, not the entire region. Same thing can be said for Chile also, same thing for New Zealand and Tasmania. This is specific to Western Europe. That is our area of interest, the most dominant place. Okay. So not really a climate factor, but more of a population factor. So high urban population density leading to the domination of two industries. Now let's talk about Tasmania and New Zealand and New Zealand's dairy industry. See, please note, you take a country like India, you take Indian breeds also, the temperature in a tropical country is very high. So once the temperature goes up, the microbial activity, be it bacteria, be it virus, be it fungi, it is going to be damaging to your commodities. And that is the reason you produce milk in a place like India. If there is no, proper storage facilities, the chances of getting spoiled are very high. See, I'm not saying that if a cow in England or a cow in New Zealand produces milk, it will never get spoiled. The point is, average temperature is low. If average temperature is low, generally because of latitude, the milk will have more sustaining time because the microbial activity is reduced, right? So that's why you keep things in a refrigerator. Same thing with reference to production value also. The cows in these regions produce more milk, more per capita compared to Indian cows. So because of these two reasons, apart from urban population, demand, milk and milk products is a major industry in New Zealand, is a major industry in Denmark. That is what we saw in map reading. It's highly relevant to climate and highly relevant to the cow breeds which are found in these places. What is the implication of this? India did not sign the Regional Comprehensive Economic Partnership, RCEP, which you would have learned in bilateral relations, because India was afraid that New Zealand's milk and milk products can affect Indian farmers. That's something which we need to take care of. So that's why India said we're going to walk away from the agreement. Okay. So that is some input on why milk industry is dominant and why market gardening is dominant. If you think back, think back to your vegetables, you would have found this is a major commodity exporting from Netherlands. It's there in map reading itself. Do link that. Is it clear? Same thing for fruits and flowers also. Okay. Belgium. Right? So that ends the discussion on map read, on human geography part. Okay. Shall I proceed further? So British climate is a straightforward, simpler one. All you need to remember is the population density is very high in northwestern Europe. Importance of flowers, ma'am, bouquet. Who cares about bouquet in rural area? Spelling, I think spelling is correct. Bouquet, right? That's why Netherlands comes into the picture, where, see, thing is, once you're able to satisfy the local demand, then automatically you can export. First, flower demand was there only in northwestern Europe. Then they started exporting to every other nation in the world. Same thing is true for New Zealand also. New Zealand's dairy industry was first localized. With increase in refrigeration, increase in transport, the products get transferred all over the world. Same for Denmark. Is it clear? So it is mostly related to your book, BOU. Okay, fine. Now to proceed further, want to add one more point. See all the discussions, if you see, I was trying to relate only to urban population density. Please note, if they ask a human geography question regarding British climate, you can talk about the other factors also. In France, we would have seen aviation sector, the importance of aviation technology, nuclear technology. And apart from that, fashion industry. You go to Britain, we had finance industry. So those points also you should be adding. These factors are actually originated because industrial revolution started here, and because of that, high level of manufacturing and services sector is present. So please don't forget that. This is just the climate, very close climate relationship and urban population density factor. Map reading notes are important. You can write that also. Apart from this, we have several other industries. Clear? So let me move to the next one. This is Mediterranean climate. So British is much simpler. That's what I told you. You spend some time on deserts. You get deserts, then the wind system is much, much easier. So let me draw it big itself. Draw it bigger. So again, equator is done. So the equatorial is done. Deserts done. British done. My Mediterranean climate is right there. My favorite climate, actually, want to go or experience it at least once. So desert climate, offshore trade winds. Okay. British climate, onshore westerlies. Right? So this is my subtropical high pressure belts and equatorial low pressure belts. So I have my trade winds below, offshore, westerlies above, Britain. In the center, I have my Mediterranean climate. Okay. I have a question for you. Desert trade wind is dominant. British climate, westerlies is dominant. Who will be present in Mediterranean climate? Right there. Yes, there. Who will be dominant in Mediterranean climate? Give me an answer. South trade wind, north westerlies. Who will be there in Mediterranean? Simple answer only. One person is sitting south, one person is sitting north. Think, I'm asking about wind and the Turkey Balkans will come. Wait, I do not even show you the map. I'm asking you if desert trade winds are there, if British climate westerlies are there, who's there for Mediterranean? I didn't show you the map. Wait. I'm asking which wind will be there. Say something. What people? No response is coming. Okay. It's like this. One is here, one is here. Where is the third one? What happened? Give some response. South trade winds, north westerly, center, it will come. Which will come in the center? Make it fast. No one responding. People, without one, at least give one response, man, and proceed further. Say something. Where is that mountain, man? Both side wind comes. Now you ask no. Now you tell, man. Stubborn people not answering at all. I won't read that answer. SAOC 2030104 because I don't understand what you've typed. 90077 correct answer. See, simple answer is both. Trade winds also will be there. Westerlies also will be there. How to? Before I proceed to that, I'll show you the map first. Mediterranean climate is special. Not because I like it, no. Because it's located in a unique region. First, we'll find the themograph and map. Bye bye British. Bye bye British. Where is my... Yeah. So Mediterranean climate. Right there. Right there. So areas which experience Mediterranean climate is even smaller compared to British. Look at this region. Mediterranean climate is experienced in areas in and around the Mediterranean Sea. See, yes, it is in parts of North Africa, but very, very small parts of North Africa. Libya, not entire Libya. Northern Libya will come. Algeria, not entire Algeria. Most of Algeria will be a desert. The coastal area around Algeria, there will be some Mediterranean climate. Same thing for parts of Morocco also. But larger section of southern Europe will be Mediterranean because these are peninsulas. So peninsulas there, water can move further in. Portugal and Spain, northern Portugal, northern Spain, British climate. Southern Portugal, southern Spain, Mediterranean climate. Italy, Mediterranean. Greece, now we are right, man. Someone told no. Balkan Peninsula, Mediterranean. Turkey, again see, not entire Turkey. Western part of Turkey. Is it clear? And parts which are in Israel also, certain parts of Israel. Okay. You come outside. You know which place is this? This is California. We spent enough time. Silicon Valley, Sacramento, San Francisco, San Jose, and Los Angeles. Okay. California. In North America. You come south. Chile. Again Chile. See, Chile is a wonderful region. I'll tell you why once I finish it. Why I like Chile. This is again on my bucket list. I want to go there. So northern Chile. Southern Chile was in British climate. Northern Chile is in Mediterranean. Fine. And very narrow portion of Africa. Very narrow portion. Cape Town. Western part again. And a very, very small portion in Australia. So north of Tasmania, you can see that. Tasmania is British. Mediterranean comes south of British climate. So south of it. Okay. So this is Mediterranean. So the largest contiguous section is in Mediterranean Sea, areas around Mediterranean Sea. In the North American region, California. In South America, it is northern Chile, Cape Town, western part of South Africa. And then you have in a very small, narrow portion of Australia, north of your Tasmania. So these are Mediterranean regions. So what exactly makes Mediterranean regions special is they experience a different pattern of rainfall because of their wind systems. I will draw the diagram, we'll understand the concept, then I'll go to climograph. Okay. Listen here. So what makes them very special? Because Mediterranean climate is actually located right where the pressure belts shift. Let me draw the diagram for you. If possible, properties of pressure belt, you would have written something. Today, we started the class with that. Third property, pressure belts shift between seasons, you would have written. Take that. Notes. Be there in your notes. Okay. Equatorial low, subtropical high, subpolar low, polar high. Let's take that in your notes. I'm going to repeat the same diagram with a twist. Hold. Equator, Tropic of Cancer, Tropic of Capricorn. This is what you drew now. I'll do one value addition to the diagram. What we'll consider is we'll find one place, okay, and we'll see what happens to the place. I'll draw diagrams of two wind systems. First is trade wind. Second is westerlies. Okay. Now I'll draw the pressure belt first. What will happen during summer season? When the wind shifted north, when the insolation shifted north, direct overhead sunlight shifted north, pressure belts move north, right? Polar high pressure belt shrunk. Now let me take one location right there. See what happens. See, during my summer season, this pink color dot which you find right here, that is the region where trade winds are operating. You got it? North of that, westerlies will be present. Okay. During my summer season, when trade winds operate on western side of continent, think back, Mediterranean, this is M, Mediterranean, this is my direction. Look at the diagram right now. Winds blows from land to sea, offshore trade winds. Offshore trade wind. So during my summer season, the speciality is there will be no rainfall. No rainfall. You got that? Now I'll go to the winter season right now. See, please note the point I have not changed. Point is in the same place. During winter season, my equatorial low pressure belt will shift further south. So it moves south. Okay. Subtropical high pressure belt will even come down. Polar high pressure belt. Subpolar low pressure belt. Polar high pressure belt expands. See what happens. Trade winds are even below right now. They'll cross to equator and blow. Okay. Is it clear? You take your westerlies. Westerlies are operating right now. So during my winter season, see what happens. Same diagram, same climate chart. Mediterranean is here. Now westerlies are operating, and when westerlies operate in this area, look at the arrow mark. Wind blows from sea to land, onshore westerlies. Onshore westerlies. Is it clear? So during my winter season, there will be rainfall. This is the most important character of Mediterranean climate. Because whenever I say this, people tell me, sir, but summer also there is rain. I see in the climograph. Please note, in regions of Mediterranean climate, the winter rainfall will be more, 3 times higher than the summer rainfall. There is a proper winter maximum because during summer season, there is offshore trade winds, no rainfall. During winter season, there is onshore westerlies. The only climatic region in the world, except Chennai, of course, the eastern coast of India, except that which experiences rainfall during winter. That's a speciality. Okay. So that is why this climatic region is present or is affected by shifting of pressure belts. That's what makes it very interesting. Shifting of pressure belts. Okay, once you've taken the diagram, you've copied it, use the word finished. So now I think the interlinking process should immediately happen in your mind when you look at it vertically. I'm focusing only on western side today. So we'll go, that's why you take one climate, you should learn 3 sets together. 3 sets complete. Then Savannah, Steppe, Siberian, 3 sets together. So it's much easier for you to relate. Climatic regions always compare and learn. You won't forget anything. This is why I told you my favorite climate, winter rainfall. Winter rainfall is 3 times greater than summer rainfall. You get 10 in summer, 30 times, 30, 10 into 3, 30 in winter. Example. Winter rainfall is 3 times greater than summer rainfall. One person responded. So 2 more responses, I'll proceed further. Ma'am, no rainfall again. No rainfall again. I'm talking about comparison. Mostly there will be no rainfall, but the point is Mediterranean regions are located closer to the sea. Due to their coastal location, there are very good chances that clouds might migrate when the winds shift. Because between summer and winter, there's a constant shifting process. Is it clear? That's why I mentioned that. Because you will ask me later, sir, in Climograph, there is a small 1 inch they're given rainfall. That's why I told you. Believe you're ready? 2 responses I got. Because the sea is enclosed by land, no? So, still waiting. Okay, fine. Thank you. We'll proceed further now. So now we have a precarious condition. Let's look at the map right now. Climograph region. Where is my, sorry. See, look at this. There is high temperature, low temperature. So where areas there is summer season, the rainfall is low. Winter season, rainfall is less. December, January, there is very good rainfall. Okay. That's what, only few inches will be there. So you guys shouldn't ask me, sir, there is some amount. It will be there when pressure belts shift. Perfect condition is not available. So winter rainfall. Now going on to the natural vegetation part. So how do plants adapt? Well, natural vegetation is exceptionally unique in this climate because we are going to talk about a new type of forest. In Gocheng Liang, they have given you 4 types. 4 types will be given, and all 4 types are there. There is Mediterranean evergreen, Mediterranean oakland, several 3 to 4. The Mediterranean grass they would have given. See, of all the varieties, one variety is the most dominant. You use this word for defining a Mediterranean region. You see the plant, you will know this is Mediterranean climate. What is the representation? What forest area? You're talking about sclerophylls. Sorry, SCL, sclerophyll forest. Clarity. This term might be new for many people. Sclerophyll means landscape dominated by shrubs. Sclerophyll, domination of shrubs. So to understand domination of shrubs, we need to understand what problem does it pose for a plant. Apart from problem posing for a plant, how does the adaptation help? See, plants grow only if you have 2 combinations together. First of all, for a plant to grow well, like really lush vegetation, you need to have 2 things. You need to have your temperature. At the same time, rainfall should be present. Correct. Mediterranean climate provides a complex challenge to plants. The complex challenge is during summer season, temperature is very good. Rainfall is not there. During winter season, rainfall is present, temperature is not there. So that's a challenge. So listen carefully. The plant should actually tide over a dry summer. Look at this combination. Temperature is high. Again, clarity. Listen. Temperature is high means not extremely high. We are talking about 35 degrees north latitude or 35 degrees south latitude. Temperature high means come in that latitudinal region compared to your winter season. the temperature cannot be as high as a desert or equator. For that region, average temperature is high, but rainfall is not there. So that's what we call a dry summer season. It's not a wet summer, dry summer. So plants need to adapt for a dry summer season. So how do I tide over dry summer? Winter, I will receive rainfall. I just need to wait this out. Okay. That is when shrubs become very good adaptations. So how do you define a shrub? Please don't say it's a bushy structure. That's not the right way to define it. Shrubs are differentiated from trees based on where they start branching. Look carefully. Okay. Let's take a bark. This is my tree. Is it clear? The difference between a tree and a shrub is where my branching position has got to start. Shrubs branch very close to the surface, like this. You've seen Christmas tree, I think. The branching will be extremely close to the ground. Okay. Close to the ground, branching. This is what you call as a shrub. So if they branch out like this over a period of time, from the bottom leaves will come. No? So automatically they'll have a bushy appearance. Bushy appearance. Is it clear? Shrubs branch very close to the ground. That gives them a bushy appearance. Shrubs branch very close to the ground, so that gives them a bushy appearance. So in Gosheng Leong, you might find a word, this climatic region, there is no shade. Climate where there is no shade. True only. Tree is there. You stand under the, it looks like a leaf. Sorry. Tree is there. There's large number of leaves, flowers. You stand under the tree, there will be shade. You will survive. Look at this region right now. Where will you go and stand? You go and sleep right there. You get it? See, advantage of having a shrub vegetation is, how do you tide over dry summer? Well, if you have a bushy-like structure where you're trying to enclose the entire core area, sunlight will be present, but sunlight cannot penetrate the core. That is why if you look at a shrub will be darker on the inside. Only the outer surface, there will be more and more sunlight. Along with this, they have this waxy coating also. Think back to waxy coating we saw in deserts, because in deserts, waxy coating allows them to reflect a large amount of sunlight. So even if sunlight is present, the 3 to 4 months of dry summer, they will be able to tide over because the core section is there. No, here. Here, it won't feel that much intensity in sunlight. So because of this, they'll be able to store water. Only outer surface, there'll be more evaporation, more transpiration. So the central zone does not experience harsh sunlight. So they are preventing transpiration. Only the outer surface, there is more and more transpiration. It's like this, we have multiple layers. The center core region, the leaves are not going to experience high temperature. So less water loss. So once winter season comes, here again photosynthesize. There's good amount of rainfall. So let's store the data again. Is it clear? So sclerophyll forest, shrub vegetation is the defining feature of Mediterranean region. Tell me whether you can move to economic development. So no shade climate. Apart from no shade climate, why they have this structure? To prevent water loss. Yes, multiple responses. Thank you. I'll move to human geography part now. Economic development, human geography. See, those who have seen the film Godfather, tell me what did not Mike Corleone, Vito Corleone was doing as the major business, apart from being a mafia head? Anyone? 29 people are participating. At least one should have seen Godfather, both parts 1 and part 2. What was Vito Corleone involved in? Or at least Mike Corleone will be eating something. Some fruit. What fruit? Or what business was he involved in legally? Legally, they were doing a business. Hmm. Happa, very good. Orange. Good, good, good. Citrus fruits, and if you think properly, Vito Corleone would actually be involved in olive oil business. See, please understand, these climatic regions are very good for citrus fruit cultivation. If the plant has a the fruit which I'm talking about, if it is having a thick outer covering, they can withstand a dry summer. Same goes for olive oil also. You have a thick outer covering. So, fruits with a thicker outer covering, okay, can survive the dry summer. So that is why the traditional activity in Italy, in southern Spain, in Greece, in California, in you can go to Chile. Anyway, traditional activity is citrus fruit cultivation and olives. Citrus fruit olives. That is why I told you Spain major export. Think back, Spain. Okay, Greece, even parts of Egypt. Everywhere, fruits and nuts will be an important activity. California is a very important fruits and nuts producing region. Now, one more change I want to add, which is not in your textbook. Apart from citrus fruits and olives, I think it can get classified in that, but it'll be specific. One important fruit is avocados. There's a rage for this avocados. There is a rage for this fruit, and avocados, one problem is they require large amount of water. And cultivation of avocados in Spain, cultivation of avocados in Chile is currently creating water problems. This is a contemporary issue. Cultivation of avocados in Chile and Spain is creating more and more water problems because avocado is like we are doing it only for demand. It's not something which is naturally growing there. Okay. So that's point one. Apart from citrus fruit cultivation, olives, what else are they involved in? Like Mediterranean climate has the best wine producing regions in the world. Why wine? Because grapes go really well there. Think back again, Spain, Portugal, France, Italy, Chile, all of them are very good in wine production. Grape cultivation. So why is grape cultivation the most preferred in this particular region? Because we need to understand what is required for grape cultivation. Viticulture. Viticulture. Viticulture requires moderate temperature and moderate rainfall. Why is high temperature damaging? Well, if you have regions of high temperature, I think it would the grapefruit. The surface of the grapefruit is extremely soft. So temperature kind of makes them rough. So they lose the quality. They become more dried. Second reason is if there is high temperature, they are increasingly prone to fungal attacks. Fungi, they can easily spread over. Now, why not high rainfall? What is the problem with high rainfall? The reason is simple. Ever seen grape plants? They are not actually having sturdy stems. They are vine, right? Vines. Okay, vine pour that much heavy rainfall, now the entire grape crop will be damaged. That is why you don't want high temperature, don't want high rainfall. You look at this, both these are present in Mediterranean climate. Temperature is moderate because of its latitude. Latitude is 35 degrees north, 40 degrees north, 32 degrees north. Not as hot as equatorial region, not as hot as tropical region. Subtropical heat, bearable for the grape. And second thing, why moderate rainfall? Think back to how rainfall is there. Rainfall is due to onshore westerlies. This is why I told you in British climate, when onshore westerlies move, they get slight elevation, clouds, rainfall. Drizzling rainfall will be there, light rainfall. Very ideal for grape cultivation. Is it clear? Not the heavy equatorial rainfall or the heavy tropical rainfall. In India, you get heavy rainfall. It pours, it doesn't drizzle. But in Mediterranean, it's again, or the onshore westerlies, you get very light rain. Wonderful for grape cultivation. And once you cultivate grapes, these are the best wine producing regions in the world. Especially southern France. Southern France is considered as the best in the world, below the Central Massif. Southern France. Okay. So these are natural, totally related to climate. Traditional industries. I believe you've taken now. Now, apart from this, what advantage does this climate proceed? See, please note, apart from this, the climate actually enables the formation or the betterment of a non-agricultural industry, and that is tourism. Think back. Tourism, we saw this. I told you, tourism is a major industry in all the Western nations. We saw Spain, Portugal, Italy, Greece. People come all over the world for this, right? Same thing is true for Chile also. Chile. Okay, so tourism is a major industry and non-agricultural, but due to wonderful climate, people come here. It's sunny for most part of the year. Okay, very good climate. Rainfall is moderate. Has many beaches. Many wonderful locations across. So Mediterranean culture is quite different. Okay, and apart from tourism, apart from your fruit cultivation, I think you know that certain level of manufacturing is present. So non-agricultural example you want, let's go to Italy. Italy leather industry. Leather industry. So this is one prominent one. And Spain manufacture of zinc, metal, one of the leading producers. So some metals are present. Is it clear? Britain also should be good for wine. Temperature problem, Raj. Temperature is too low, isn't it? You're going like 50-degree north, 60-degree north. Temperature won't be there. You got the idea, Raj? Temperature problem. Too cold, na, then frost action will come. No? How will you grow wine there? Mediterranean, not as harsh as equator desert, not as cold as Britain. Exact center. Ideal climate. Okay. Rainfall, okay, but temperature problem is there. Okay. So that ends the discussion on climate. And please note, when it comes to population density, Mediterranean regions are quite dense in population again, very high population density. Okay, like because the area is very, very low. Okay. So shall we proceed to the next one? Just tell me. Okay, fine. So that ends the discussion on your western margin climates, people. Along with human geography, we have finished. How things have changed, how things have grown. So equator is done. E, deserts, British, Mediterranean. Please make sure you revise your notes, and after revising your notes, read through all the chapters. Like it'll be easy for you. Because class notes and read the class notes, immediately go to the book, the work will be over. Now you need not strain much at all. Got it? So next weekend, possibly I finish temperate cyclonic systems. I'll go for the second set. This is one more easily connected. Savannah, Steppe, and Siberian. Is it okay? So now we'll go to cyclonic systems. But before I go to cyclones, I just want you to do this alone. Since I finished the 3 climate set, not much. Take 3 minutes alone, not a break. Not a break. 3 minutes. I just want you to go through the pages and the wind system change that alone. Just flip through the pages. Climatic regions alone, you see. Okay, doubts I'll handle at the last. If any doubts, so they just circle and keep. Post 7:10 or 7:15, we'll handle doubts. Go to cyclones. Can you tell about dates in desert? See, date palm cultivation doesn't require any water. And if you look at the fruit also, it is a natural plant of the dry lands. That is why they produce dates. It's very natural. It's something which is part of the desert landscape. Okay. 3 minutes. I just wanted to go through any queries you find, just circle and keep. We'll just see it immediately. Okay. Meaning 7:10, 7:15, that time. one more minute. Because we'll be again going back to climatology. So the entire tone of class will change. We won't be looking at human geography again for some time. So cyclonic systems. And first is tropical cyclonic systems. Right. So going back to climatology, and we are going to start with, okay, one question. In 11th NCRT, we have Köppen's scheme of classification. Is it related? Okay, CRBLR 2041625. Köppen's classification system is not required, that chapter. I tell you again, that is related to optional syllabus. No, 7 or 8 years back, UPSC was asking questions on Köppen classification. Now we can safely ignore. They moved on from that. Doesn't matter. You can ignore the chapter, Köppen's classification. Okay. Okay, fine. Let's start with cyclonic systems. Ready. You know, even though the name seems quite dramatic, it's actually not that dramatic. Meaning, cyclones are nothing but low pressure systems. That's all. Okay. Low pressure systems. Low pressure systems are classified into depressions, storms, and cyclones based on wind velocity. That's all. Based on wind velocity. Okay, so depressions have a wind velocity around the low pressure center of less than 40 kilometers per hour. If the wind velocity is between 40 to 120 kmph, 120 kilometers per hour, you call it as a storm. You exceed 120 kilometers per hour, you call it as a cyclone. That's all. The cyclone is nothing dramatic when you look at it geographically. Just looking at a low pressure system, the low pressure system can have 3 different velocities. Less than 40, call it a depression. 40 to 120, call it as a storm. And more than 120, call it as a cyclone. So even storm and cyclone, no basic difference. Just the speed, that's all. Your velocity, that's it. I believe you got it. Based on wind velocity. Hold on for a few more seconds and flip over. 15 seconds. Less than 40, 40 to 120, greater than 120. I'll give you 5 seconds. It's really not complicated. 5, 4, 3, 2, 1. Now, how do you classify cyclonic systems? Well, cyclonic systems can be broadly classified into 2 parts, tropical and temperate. Tropical. Again, you can have tropical disturbance, tropical storm, tropical cyclone. Okay. For example, tropical disturbance is what, your, I don't know to say this in English, but your weatherman says, the low pressure system develops into a cyclone. In Tamil, they say, காற்றழுத்த தாழ்வு மையம், a depression. Okay. வங்கக்கடலில் உருவான காற்றழுத்த தாழ்வு மையம், a low pressure system which opens over Bay of Bengal. A depression which is over Bay of Bengal. That can turn into a cyclone. Wish I had known Malayalam, Kannada and Hindi. All 3 languages, clean bold. I know only English and Tamil. Really sorry. So I couldn't say the regional term. So coming to tropical cyclones and temperate cyclones. And tropical cyclones, it's only based on latitude, found between the latitudes of 5 to 25 degrees north and south. That is where they form. Temperate cyclones is above 45, 65 north and south. That's the area of their operation. Just based on latitude, where the cyclones form, Tropical region, call it tropical cyclone. Temperate region, call it temperate cyclone. Today we'll be seeing about tropical cyclone alone. The ones which we are familiar with, okay, which comes and attacks India. Is it clear? Believe you're ready. Tropical temperate, just the variation latitude. Start from this. Tropical cyclones. The tropical cyclones occur or form between 5 to 25 degrees north and south. So first we need to understand, why do cyclones form, or when does a cyclone move from a depression to a storm to a cyclone? We'll investigate that. First, we need to connect something, conditions for formation. Before we understand conditions, simply know what a cyclone is. A tropical cyclone is nothing but a mechanism used by the earth to transfer heat energy from the tropical region to temperate region. That's all. That is why, if people say that if you're going to increase global temperatures, global average temperatures, if there is going to be more climate change, then the tropical cyclones will increase. There is more temperature in tropics, heat will be transferred. I think you remember heat budget, right? So cyclonic mechanisms are nothing but heat transfer mechanisms of the earth. So conditions for formation, we are talking about areas which will have large amount of heat and moisture. The first one, we're looking at shallow water areas. Shallow water areas with the temperatures greater than 27 degrees Celsius. Shallow water areas with temperatures greater than 27 degrees Celsius. Is it clear? Why again? We'll compare. Because there needs to be proper clarity here. Shallow water region, the volume of water is going to be low compared to deep water. So if you're going to heat with the same amount of insulation, since the levels of water which needs to be heated is much less, this will easily get heated up. Okay, you can't escape. But deep water areas, it's not possible for heating the entire layer. That is why cyclone formation is heavily restricted to the shallow water zone. Not the idea. Second thing you need to understand very clearly. Look at the word I used. I told you conditions for formation. Conditions for formation. Formation will happen in shallow water. But once it is formed, it can move over deep water. That is not a problem. It's like starting the vehicle. Starting the vehicle is very difficult to put it in upslope. Downslope easy to start. Once you start the vehicle will run everywhere. Meaning, makes sense. Forms over shallow water, but it can easily move over deep water. Difference is there. Shallow water areas, less volume of water, so much easier to heat up. Okay. I believe you've taken the first one. Going to point 2. Okay. Yeah, going to point 2. Now, this low pressure region, surface temperature influences air temperature. Surface temperature is hot. Surface temperature is hot right now. Air temperature is hot. So air is going to begin to rise. See, when air rises, there are two ways. The second condition is important in this case. So please note, two things should happen. Air rises, what pressure will you create? Low pressure. Air is rising up. Low pressure here. Low pressure here. Condition 2 and condition 3 is important. Listen, condition 2 is you should not have, let me write it, there is absence of vertical wind shear. Vertical wind shear. Vertical wind shear is nothing but change in, let me write that here, that is change in wind velocity, change in wind velocity with altitude. Vertical wind shear, change in wind velocity with altitude. Meaning, wind, you know the definition, no? Horizontal movement of air. You want an ideal condition. Let me draw the ideal condition on the left side itself. Ideal condition, this should be the case. Like the wind velocity is same, almost same. Not much variation. If the wind velocity is different, you know what will happen? So let's say this is slow. Slow at the surface. This is faster. This is much faster. These type of conditions will collapse the cyclone. This condition only will survive. You know why? Because once air rises up, no, this structure, this column structure should be maintained. If you take high vertical wind shear, look at the meaning. There is absence of vertical wind shear. Here there is no vertical wind shear. Vertical wind shear means change in wind velocity with altitude. If there is higher change, you know what will happen? Air is rising out, isn't it? It will get diverted. The cyclone will actually collapse. Is it clear? You can't form a proper cyclonic system which will stand on its own. It will collapse due to vertical wind shear. This is point 2. Absence of vertical wind shear. Tell me you're finished, I'll go to point 3. Structure should be strong. That's why. The uprising of air. You're just forming. We haven't formed a cyclone. You're just forming, slowly forming. Third one will go. Okay, thanks for the response. We'll move to the third one. So you shouldn't break it. Third one, if you want to continue formation or if you want to intensify your depression, proper divergence in the upper atmosphere. Proper divergence in the upper atmosphere. Let me explain. Again, ideal conditions, surface temperature influences air temperature, low pressure is formed, air rising. Okay. Surface temperature influences air temperature, low pressure is formed, air rising. Divergence means convergence na joining. Divergence means spreading out. We are talking about divergence in the upper atmosphere. People listen, once it rises, it is essential for the cyclone to survive that the air moves out in both these directions really well. In non-ideal condition, no, right side. The air doesn't spread out properly, there will be accumulation here itself, right? If it doesn't spread really well. In this type of accumulation, it's like you're putting a clog in a vehicle. You put a clog in a vehicle, air cannot rise up. If air doesn't rise up, the cyclone cannot have the circulation speed. Ideal condition is this. Proper divergence. It spreads out on top, space is created, more air will come, space is created, more air will come. The circulation will be very, very good. See, proper divergence in the upper atmosphere. This will block the cyclone. I mean, this will block the development of the cyclone. Ready? Still, I haven't come to the mechanism yet. Now, mechanism will come. So, proper divergence in the upper atmosphere. Before that, less vertical or absence of vertical wind shear. Before that, shallow water areas which have temperatures greater than 27 degrees Celsius. Now, we are going to hit the mechanism. Listen. 4. You can say mechanism or point 4. Both are conditions. See, low pressure areas created means wind will come and they will move up. Listen carefully. This is where you bring all that knowledge which you learned in your physics. We just saw right now, isn't it? Simple. Air moves up. Cloud formation will happen. Adiabatic expansion. Correct? Simple, people, don't make error. Once cloud formation is happening, gaseous state, now it is going to convert it to liquid state. That is only cloud, no water droplet. Please don't make error. You tell me latent heat will get released or absorbed when clouds are forming. Latent heat will get released or absorbed when cloud is forming. You got this cyclone over. That's all. Simple. Think high energy, low energy. Give me the answer. Correct answer. Good. Good. 2 answers right. 3 answers right. Appa. You got the idea. Gas is at higher energy. Liquid is at low energy. So when you move from higher energy to lower energy, automatically latent heat will be released. This is the foundation for tropical cyclone, people. See why I'm saying latent heat energy. Madam, absorbed, madam. How, madam, absorbed? Gas, high energy, madam. High to low, you'll release now. I told you, jumping down. Look at your notebook. Now come back. Cloud formation is happening. See, when cloud formation happens, this is where you understand latent heat. Latent heat is not sensible. These air passes are located somewhere, different parts. For example, let's say the low pressure system is in center of Bay of Bengal. So water vapor from different parts of Bay of Bengal are coming towards the center. They are rising up. In this location, latent heat which is collected from different parts is actually getting released. Can you imagine how much energy will be there? So once you release large amount of latent heat, which means there is more and more energy. If there is more energy, air passes will rise up faster. They are using that extra energy. That is why latent heat is important. This energy they're not showing to anyone. So far, you can't measure anyone. Now you'll have to release because condensation is happening. Once you release energy, which means you'll vertically move up, using more and more energy for moving up. Listen, space will be created here because they're moving up, they're using latent heat. Now, more and more air passes will come. This is a positive feedback loop where more air passes come. More air passes come, more vertical rise. You rise up faster, more release of latent heat, more vertical upward movement. This is a positive feedback loop where due to release of latent heat, the air passes consistently rise up further, releasing large amount of heat, and that creates more and more space, allowing air passes from outer areas to come towards the low pressure faster and faster. So please note, latent heat released. Okay. The release serves as a positive feedback loop. Serves as a positive feedback loop for the heat engine. It's technically a heat engine, a tropical cyclone for the heat engine, which results in more winds moving towards low pressure system. Moving towards low pressure system, LP. Moving towards low pressure system. Got it? So simple concept, latent heat is released, which means air energy which was not there anywhere, now it is getting released here. Passes will use that and move up. Space created, more and more invitations. Please come and join us. We are releasing large amount of heat, okay, which we haven't used so far. It's technically a heat engine. The release serves as a positive feedback for the heat engine, which results in more winds moving towards a low pressure system. It's like throwing basketballs more and more and up. You're just passing it over. Vertical rise, vertical rise, vertical rise. Shall we move? Let's see how the circulation operates now. We're going to circulate right now. Still, so far, we've never seen any rotation. Now, rotation is going to happen. Yeah. See, now, once large amount of air passes release, we never focused on the low pressure. This is when the low pressure system is getting more intense. So, if it gets more intense, then only a problem will come. Low and higher relative terms. So once low pressure areas there, surrounding regions. So center of Bay of Bengal, some region near Myanmar, some near Bay of Bengal, some near Odisha, Andhra. So let's say on high pressure region is there. Wind blows from high pressure to low pressure. See what happens? Pressure gradient force. Very good person. See, if some center is there, I will try to go and sit. Maybe assume one chair is here. I'll go and sit. Oh, high pressure, low pressure, trying to go and sit in this place. Problem is, one individual will not allow me to come and sit in the low pressure. You know whom? When I try to come fast and sit in low pressure system, one stupid person will come and disturb me. His name is Coriolis force. He'll be like, sir, you're not supposed to sit there. Please go right. The low pressure system, I want to go and sit. I am a pressure gradient force. I am Coriolis. Push right. You get it? So over a period of what happens is, listen, we try to sit, You push towards the right side, you still can't sit. Again, you push towards the right side. So instead of going and sitting in the low pressure system, you're trying to cast a low pressure system, but you move in this direction. You look at the low pressure, you want to go, but Coriolis force will push you towards your right side. This is my right side. It works like this. More speed, there is more Coriolis force. So Coriolis force, right side, Coriolis force, right side, Coriolis force, right side. You combine all of them, resultant, join all of them. See the rotation right now? That is how we establish a proper rotation. Low pressure systems in northern hemisphere move in an anti-clockwise direction. Southern hemisphere opposites. That's how the cyclonic circulation is established. Only because of Coriolis force. That's why I told you. This guy is very essential. If he's not there, Coriolis force is not there, high pressure will go and occupy. Low pressure sealed, that's all. Cyclone is dead. Okay. So northern hemisphere low pressure system as in anti-clockwise direction. Low pressure, anti-clockwise direction. This is how it's got. See now, problem will actually come. Thing is, circulation will happen, but even though circulation happened, no one is able to go towards low pressure. Coriolis force is preventing. Now, what is a normal low pressure? Due to Coriolis force, will become more and more intensified. 995. Apart from circulating anti-clockwise, this circulation is there. Now, along with rotation, vertical movement is also there. They move up. So, more and more air rise. Low pressure becomes from 995, 993, 990, 987, 985. Slowly, it will keep on declining. So, if it becomes more and more intense, more winds will come. Again, velocity will increase. That is when depression becomes storm, then storm becomes a cyclone. Very slow process. Is it clear? Very slow process, but consistent process. I believe you've taken on. Shall we go and get the structure of cyclone? This now I think we can fill it up. Structure. The vertical one, the huge vertical one. You'll finish it off, then the entire set will be ready for you. How things got formed and how does it look like? One response. Thank you. I'll proceed further now. See, first, this is how it looks like. Don't draw this diagram and tell you how it looks like actually. Low pressure, high pressure, high pressure, high pressure, deflection, deflection, deflection. Get it? So the anti-clockwise circulation is starting. Two motions will be there. Circulatory motion anti-clockwise along with that vertical motion. Move like this. Think back. Once it vertically moves up, what did I tell you? There should be divergence. So once it reaches up, the air spreads over in all directions. So you get huge amount of cumulonimbus walls and all. This is what happens. Air diverges in all directions. It moves like this. Diverges, diverges, diverges. Spreads out everywhere. See that? This is your cyclone, people. Is the diagram clear? Is this clear? This is how it actually looks like. Idu purinjada? The thing is, don't draw this in exam. You know why? Even though this is how it looks like, okay, convergence at the bottom, divergence on top, vertical movement, along with the rotatory circulation anti-clockwise, everything is okay. You draw the diagram. First, you yourself will not understand. Examiner, you yourself won't understand anything. Examiner will not understand anything. You draw this, now mark won't come. That is why I'm saying. It's not that diagram is incorrect. Diagram is correct only. Is it clear? But problem is, mark won't come. So for exam purpose, draw this diagram. We'll cut that, three-dimensional, we'll cut it into 2D. Structure of cyclone. Draw this. This is enough. This one. Simply puts this. That's all. Simply say that there is a anti-clockwise direction. Okay, anti-clockwise rotation is there. This symbol will do. Then vertical movement is there. Air is converging. Vertical movement is there. So what is this area? So you see, please note, now this is where we understand the structure. Air is moving up vertically, isn't it? Listen and then you can copy. Listen, air is moving up vertically. Air is doing work, which means adiabatic expansion and cooling. So this is the area where there is large amount of cloud formation. I'm not using the blue color, but please understand, these two other sections, these are my cumulonimbus walls. Surrounding the center, see, the entire region is low pressure, including the area where there is rainfall. That is why entire area is moving up. Entire area is low pressure. And these are the regions, these are cumulonimbus walls. I'll write it here, cumulonimbus walls, nimbus. So many clouds will be there. And that is when you get this extremely high amount of rainfall. But there is one problem in a tropical cyclone where you can actually get no rain in the center. That's surprising. This is what is called as the eye of the cyclone. Eye. The eye is surrounded by cumulonimbus clouds and rainfall everywhere, thunder, lightning. How does the eye escape? Eye escapes because of this. See what happens. Air can rise only up to tropopause. After hitting tropopause, listen, after hitting tropopause, air diverges in all directions. Look at the previous diagram. Air diverges out in all directions. But when air is diverging in all directions, some air will converge towards the center. No, I'll use one more color. Some will converge towards the center. Is it clear? When all of them converge towards the center, where will they go? They'll collide with themselves. Can't go top. Where will they settle? They'll move down. They'll move down. Is it clear? See what happens. This is what I'm going to represent right there. But in simpler terms, air moves up. Not possible for me to, two possibilities. Either you move away, diverge, or you converge. So when I converge, I meet. Once I meet, collision is there. You can't move either side. Every side you're covered. Can't move top. You'll move down. Once what you're experiencing here is adiabatic compression. This area. Adiabatic compression. Once there is adiabatic compression, cloud formation is not possible. Very small area, a few kilometers only. But here alone, cloud formation is not possible. So after settling down, see, this is one more crucial point. These air passes doesn't reach the base actually. Set is in a high pressure, no, not that. Doesn't settle base. Once they undergo adiabatic compression, there will be heating. There will be heating. Heating will generate more and more energy. When they get enough energy, they will rejoin the circulation here. Adiabatic compression causes heating. Heating is nothing but there is more energy. Once they get energy, they will rejoin the circulation. So you'll have circulating eddies here also. That is why in the eye of the cyclone, there is no rainfall. No rainfall. But surrounding the eye everywhere, 100 of kilometers, heavy rain here, heavy rain here. Visualize this in 3 dimension, not 2D, 3D. The small eye portion around, there is no rain due to adiabatic compression. Okay. Eye of cyclone is similar to doldrums. Now, the rising part is okay. The rising part is totally fine. But this is something which we didn't speak about doldrums. Your understanding of this uprising is okay. That is totally fine. But this is different. Okay. That's why it's not exactly doldrums. One segment is okay. The upper divergence is different. If you're done and copy it down, use the word finished. Okay. See, now still it's not done. I've taught you how the cyclone is formed. See, this cyclone can sustain itself forever, but no cyclone lasts forever. Because when cyclone moves, it is going to die. So we need to discuss, when does a cyclone move? How does a cyclone die? Why does the cyclone die? And and why do cyclones don't form near the equator? So 3 more questions we need to understand and answer. So take a break for 5 minutes. 5 minutes. When we come back, we'll continue from here. So I believe we can finish tropical cyclones early. If I finish that, one small topic is there. Basics alone I need to introduce. It's called Jetstream. I'll introduce Jetstream, then I'll take questions. Okay, 5 minutes. So we'll resume the discussion where we left off. So yes, it's a heat engine. The heat engine is not going to stop. So first we need to understand what can move this heat engine. So movement. See, there are two ways in which the cyclone can actually move. Okay, and one type of movement is that it tries to move north, and the second type of movement is tries to move from eastern side to western side. First, they'll establish the why it tries to move from south to north in most places on Earth. Okay, so if you look at the basic movement between north and south, tropical cyclones, tropical cyclones have this general south to north movement. So they'll start from the tropical region, sorry, like south to north. I'm talking about northern hemisphere so that you don't get confused. South to north and north to south. This is their movement. Northern hemisphere. So equator I'll draw. Equator. So from the equator, they move away from the equator and move towards the polar region. Poles, poles. Yeah, so south to north can't be a generalization. I do understand. So south to north in the northern hemisphere. So north to south in the southern hemisphere. Meaning makes sense, I believe, because tropical cyclones are essentially heat engines to transfer heat. Transfer heat. So they move away from equator towards polar region. Away from equator towards polar region. So this is basic. So if it's formed in Bay of Bengal or it's formed in, sorry, if it's formed in Atlantic Ocean or it's formed in Pacific Ocean, moving away from equator. This is basic type 1. Moving away from equator. So rather than the word north to south, south to north, I think this is much easier. Just understand it as moving away from equator. We'll see the direction for southern hemisphere later. Fine. I think this is fairly simple. Now we're going to understand that predominantly most of your tropical cyclonic systems move from eastern side to western side. See? This is where you understand the role of a very important system. See? Cyclonic systems are extremely strong. The diameter can be, the entire diameter can be 50 to even 100 kilometers. So if you want to move an entire area, 100 kilometers heat engine, you need something extraordinarily powerful. And there are only two wind systems which are extraordinarily powerful. One is permanent wind system, which flows close to the Earth's surface, and the second one is upper atmospheric wind system called jet streams. And the wind system which we are concerned about is there are three permanent winds. Yesterday we saw three of them, and today we applied them. Three winds are trade winds, westerlies, and polar easterlies, called as permanent wind system. In these three winds, the wind which is capable of moving tropical cyclones is mostly trade wind system. Why trade wind system? Because cyclones occur between 5 to 25. Think back to the diagram again. Equatorial low, subtropical high, subpolar low. Subtropical high. So you have your trade wind systems moving from eastern side to western side. Is it not? And this is the region where your tropical cyclones are also forming, right? That is why trade winds move them from eastern side to western side. That is their primary movement. They move from eastern side to western side. Sorry, I drew the diagram wrong right here. Realize it. There's convergence like this. That's how trade winds are. Okay. Clockwise. Yeah, now it's fine. Trade winds move them from eastern side to western side. Still, I haven't come to cyclone tracks. I need to draw the diagram. So two movements moving away from equator towards polar region. Second one, eastern side to western side. We'll see what happens when we combine both of them. Tell me whether you're finished. Just let me know. One response. Yeah, thank you. Now we'll come to cyclone tracking. Now, how do they exactly move? If you cyclone track, so if you look at their movement in different parts of the world, okay. So West Asia, India, Sumatra, Australia, Europe, Siberia. Listen here. Equator, Tropic of Cancer, Tropic of Capricorn. Look at your cyclone movements. North of the equator, this is my movement. We'll start here. I'll draw the diagram for you. North of the equator. Condition is moving from equator to polar region. Sorry. It didn't change. Okay. Condition is moving from equator to polar region. This is the direction. Second thing is moving from eastern side to western side. This is the direction. Final resultant will be here. You get it? That is why cyclones in your Atlantic Ocean attack USA like this way. All your cyclonic systems. Is it clear? This way. These are called as hurricanes. You come to your South China Sea, Western Pacific Ocean, again cyclone. Attack China, attack Philippines, attack the Indochina Peninsula. Got it? So that is my direction right there. Next part, come to Southern Hemisphere, moving away from equator, this is the direction. Second is western side to, eastern side to western side. This is the direction of trade winds. You move like this. You get it? So the attack cyclones are present here. They attack like this. These regions. Is it clear? They attack Australia also. Okay, so they move towards Australia in Southern Pacific. These are the general cyclone tracks across the world. Is it okay? So moving away from equator and at the same time moving to eastern side to western side. I know that I haven't drawn India intentionally. Wait, India is a special case as always. Okay. India is always a special case. See, why you should apply this, why am I drawing cyclone tracks is, globally, between eastern coast of the world, eastern coast and western coast of any country you take, it will be the eastern coast which will experience high amount of problem. Example, you take North America. 2 cyclones are there. Take the eastern coast. Trade winds move from eastern side to western side. So because of their movement, the cyclones are getting pushed towards the eastern coast. Here only cyclonic attack will come. You got it? But you take your cyclones which are formed in the Pacific Ocean, they'll be moved like this way. So western coast of California, the western part of Mexico, lower California has no problem. That is why cyclonic attacks is mostly concentrated on eastern parts of the world. More cyclonic rainfall. When it comes to tropical region, eastern part has more cyclonic rainfall. Example, take North America, eastern side and western side. Now things are settling in your mind. Okay. Tell me whether you're done. That last point especially. Finished it, use the word finished. I know India is pending. I'll come to India next point. Okay, good. See, now we're going to look at India specially, even though Indian geography is there, but still, since I'm dealing with this, I'll give you some information. Because we're going to look at timing also, that's why. See, India is a special case because India experiences monsoon climate. And the thing about monsoon climate is you will experience reversal of wind systems. When you experience reversal, southwest monsoon is present, northeast monsoon is present. Okay, so this is close to my summer southwest monsoon. Then I have my winter associated with northeast monsoon. And now we should understand, why do we have more cyclones hitting West Bengal, Odisha, Andhra Pradesh, Tamil Nadu compared to Kerala, Karnataka, Maharashtra, Gujarat, Goa? It's not that these western states are not receiving cyclones. They will also receive, but very, very rare. Why is that? That is why you need to understand time, frequency of cyclones. See, please note, frequency of cyclones is high during winter season. High during winter season, because this is when water is at a higher temperature, or seas are at a higher temperature. Higher temperature. So that is why winter season the cyclones will form anti-clockwise direction, and these cyclones will be pushed towards the coastal area. That's why these eastern states face a wrath of tropical cyclones more compared to the western brothers and sisters. Is it clear? So more frequency. That's why India took it as separately. India, you don't have the dominance of trade winds. Monsoon winds are the most dominant ones. So between seasons, the movement of cyclones can change. So that's why I told you it's very rare. Rarely only during summer you'll create a depression. Is it clear? And only then you can move towards Gujarat or Karnataka or Kerala. So far we have not talked about the death of the cyclone. Next comes death or decay of the cyclone. And then relation between IT season and equator. I believe you've taken down. Okay, I'll proceed further. This is a fairly simpler concept. Southwest monsoon, northeast monsoon. So cyclones form more during winter, and during winter season, northeast monsoon is dominant. So because of that, eastern coast experiences more cyclonic rainfall compared to western coast. Tropical, that's why I stressed in the previous one also. Tropical region, temperate region will be different. Please wait for that. I'll proceed further. Now we're going to talk about decay of cyclone. Decay or death of cyclone. Tropical cyclone. See, this essentially happens under one simple condition. The condition is the cyclone should make landfall. What is the meaning of landfall? This cyclonic system which you find right here will not be always constant. It's constantly moved by trade winds. So when there is, we draw it inside itself. Yeah. So let's say the cyclone is moved towards land. Let me draw it inside. When it is moved towards land by trade winds moving from eastern side to western side, the problem is it will lose its moisture content. As long as the cyclonic system is actually in the sea, there is immense amount of moisture supply. Because of that, low pressure system is extremely dominant. There is very good circulation. Once the cyclone moves to land, it's cut off from its moisture supply. You cut off moisture, there is reduction in source of latent heat. Reduction in source of latent heat when it makes landfall. When it makes landfall. Makes landfall, and the cyclone slowly dies. And the cyclone slowly dies. But before that, it will create death and destruction, of course. But once it has reached land, within a matter of few hours, it will die. Now, people from Tamil Nadu will tell me, sir, there was one cyclone called Gaja. See, please note, cyclone Gaja is an exception. It's not an example. Those who do not know Gaja cyclone, few years back in Tamil Nadu, Gaja cyclone entered Tamil Nadu, stayed in Tamil Nadu for a few days, and then went to Kerala. It's an exception. Very, very rare case. Extremely rare. And moreover, the shape of India is a peninsula, so the area is very, very narrow, very less land. That is the reason it was able to do it. So Gaja is an exception, not an example. When tropical cyclones make landfall, due to absence of moisture, they will die because they don't have support of latent heat. Taken down. So I think all points are clear. Now we need to end with the relation with equator and ITCZ. I'll go there. Because when we discuss Coriolis force, I did not tell you about one point, how Coriolis force varies. So let me tell you this. Relation with equator. So 2 points. First, I need to refresh you for this. So you take the equator, compare it with the North Pole and South Pole. Coriolis forces 0 at the equator, 0 at the equator, and maximum in the polar regions, and maximum in the polar regions. I'll give you the reason also. Listen, it's very simple to understand. Coriolis force is simply about deflection, right? When you talk about, oh, it's not there. When you talk about deflection, you'll need to have more change in radius. Yesterday we established Coriolis force is maximum, only because of change in radius. So if change in radius is more, Coriolis force will be maximum. Take polar region. Between two, you move more and farther to poles. The radius change will be very, very high. Is it not? Radius change. So smaller to larger, larger to smaller. If you're very close to equator, 0 to 5, 0 to 5, between 0 to 5, the radius change won't be much at all. If the radius change is less, angular velocity change is less. Angular velocity change is less, automatically deflection will be less. Okay, the reason is more change in radius, more a change in R. Del enough, you won't understand. Let me write, wait. More change in radius, so more deflection, poles. Here, less change in radius, less change in radius. So because of that, Coriolis force is 0. Makes sense, because more change, more deflection. Now come to this one. Tropical cyclones do not form near the equator, because Coriolis force is absent. Without CF, without Coriolis force, circulation cannot be initiated. Circulation cannot be initiated. Coriolis force is the guy who is turning everything. No, if he is not there, automatically low pressure system will be filled. There is no concept of rotation at all, no cyclone. That's all. Okay. Once you're finished, use the word finished. There's one last point. Then we'll just take the set of tropical cyclones. We'll just quickly go through the slides. 2090077, most active person. One person is using the word not finished. SIAOC2030104. Finish. Finish. Who's finished, man? Finisher. Last point, relation with ITCZ. Intertropical convergence zone. See, please note, ITCZ helps in the development of cyclone. Helps in the development of tropical cyclones. Tropical cyclones. Because it is a low pressure system, that's all. Tropical cyclones, because it is a low pressure system. Low pressure system. Is it clear? Simple. ITCZ, this was the structure. Remember, this is ITCZ. Low pressure. This is cyclone diagram I showed you. So if ITCZ is there, cyclone will develop. Now only clarity should come. See, please note, this is equator. ITCZ can be north of equator. Here possible, north of equator. ITCZ can be exactly at equator, position 2. ITCZ can be south of equator also, position 3. But please note, position 1 cyclone will come. Position 3 cyclone will come. position 2 cyclone won't come even if ITCZ is there. The reason being, in equator, Coriolis force is not there. So if they give you a statement, please be careful. Equator, no tropical cyclone. ITCZ, tropical cyclone. ITCZ on equator, still no tropical cyclone, because in equator there is no Coriolis force. That's all. Okay. So that's the last discussion on your tropical cyclone part. Now I have one small segment, geostrophic wind. I prefer I finish that. Shall we go to geostrophic wind? Geostrophic wind, and after that I have jet stream. Then I thought I'll take doubts. Okay, fine. So we'll finish that, then I'll take doubts. It'll take only 10 to 15 minutes. So we'll be on time. Few more slides. Yeah, that would do. Geostrophic wind. Simple concept, see. Write the definition first, then I'll explain. Winds blowing in higher altitudes when balanced by PGF, pressure gradient force, and Coriolis force attain constancy in speed and direction. These are geostrophic winds, that's all. Geostrophic. Winds blowing in higher altitudes. Look at the word right there. Most important word. Higher altitudes, when balanced by PGF and CF, attain constancy in speed and direction. It's called as geostrophic wind. You might be thinking, where is friction? Oh, let me explain. Wait. Winds blowing in higher altitudes, when balanced by PGF and CF, attain constancy in speed and direction. Proceed further. The simple logic, see. Three forces are there which will govern wind. Friction is there, PGF is there, CF is there. But all of them present in third level. Mountain, building, tree, car, everything. Surface level of frictional force is very dominant, no problem. Wherever the wind goes, frictional force only will dictate everything. And so much obstruction, so much problem. I'll take the same blue color line. I'll shift it 4 kilometers, 5 kilometers above the surface of the earth. Once I take the wind to higher altitudes, only if land mass is there, resistance will be there. Land itself is not there, which means frictional force will almost become negligible. You can't say it's totally nil, because within winds there might be some resistance, but we can definitely say it is negligible. See, three-body problem is very complicated. Now, these three bodies have taken one outside, so this becomes a two-body problem. Two-body problem, it's very easy to find balance. Three forces are there, and it's very difficult for you to determine who will pull in which direction. Now, this is a two-body problem. You know what will happen? See this. Please note, higher altitude. I'm not talking about surface. Visualization. Is it clear? I'm not talking about the winds is moving here. I'm talking about the winds which move here, up, high altitude, 4 kilometers, 5 kilometers. What will happen is, in high altitudes, if we find a high pressure system, a low pressure system, pressure gradient will push you towards this, right? This will be deflected by Coriolis force towards the right side. So many times you've seen today itself. Over a period of time, this will be the resultant. Okay. PGF will try to push in one direction, Coriolis pushes in another, again. At one point of time, both PGF and Coriolis will balance each other. That is called as geostrophic wind, the green color one. Every point you take, one point there will be perfect balance. This is called as geostrophic wind. This is made possible only because frictional force is not there. Friction is there, entire thing will get collapsed. Okay, so this is called as geostrophic wind. See, please note, it's in higher altitude. Never ever forget that. This is very tall. It's very, very high. Okay. So high to low. Oh, I drawn the direction wrong. Okay, I'll just change this. Thank you for reminding. High to low. High pressure to low pressure. Thank you. Then deflection. Okay. High to low. Green is geostrophic wind. So geostrophic winds is a simpler concept. Nothing really dramatic. Now we're going to look at a subset of geostrophic wind. It is called jet stream. Fine, jet stream. I believe you've taken the diagram down. Simpler one. You yourself have drawn it several times. Jet stream. Again, let me repeat. I'm giving you the basics of jet stream only. Just the basics of jet stream. How jet streams affect cyclonic systems, we will see when I come to temperate cyclones. Okay. So what are jet streams? Jet streams are special cases. Let me write it. Jet streams. These are special cases of geostrophic winds. Geostrophic wind with some speciality. What speciality? Well, one by one. They are long, narrow, fast flowing, meandering. Long, narrow, fast flowing, meandering. So if you're having a checkbox and if you want to qualify, okay, this is a geostrophic wind. Does this geostrophic wind have jet stream or not? What qualifications do you look? Long. How long? Several thousands of kilometers, several hundreds of thousands of kilometers. There are certain jet streams which cover the entire earth. Long. Check. What do you mean by narrow? Narrow meaning we're not talking about thousands of kilometers, but few tens of kilometers. Compared to the length of the jet stream, the width of the jet stream will be very, very less. So high length, the width is very, very low. Extremely low. Check. Fast flowing. How fast? 100, 150, 200 kilometers per hour, at times even 250 kilometers per hour. Extremely fast. Check. What do you mean by meandering? Meandering is you don't flow in a constant direction, a straight line. You become very wavy. This is meandering. If all these components are satisfied, then you call it as a jet stream. Now, basically, jet stream can be classified into two types, global jet stream and local jet stream. I will be teaching you global jet stream alone. That is required. Local jet streams you'll see when you come to India. Indian geography, they teach you. So, global jet streams. Okay. So, broadly divided as global versus local. Global versus local. We're going to look at global jet streams alone. So, its features. Number one, encircles the entire Earth. Encircles the entire Earth. Full Earth it will cover. Number two, present throughout the year. Present throughout the year. I'll show you animation where they are. Before that, let's understand, just like yesterday. Present throughout the year. Okay. Present throughout the year. So long, narrow, fast-flowing, meandering geostrophic winds are called as jet streams. Broadly classified as global and local, and global jet streams are present throughout the year and they encircle the entire Earth. Believe it taken. Now only we need to picture it, like where exactly do they operate, global jet streams. See, there are totally 4 global jet streams only, 4 of them. And 4 of them are highly restricted spatially. Geostrophic winds are horizontal or vertical. Raj, it is horizontal. That's why I was insisting. See, the winds move in this direction. Okay. Think about the word, the basic concept. Wind means horizontal motion. There's confusion should never come. Vertical, I'll use the word convection. Wind is horizontal. Okay, let me show you. See, where they are. Wind itself is horizontal word. That's all. Totally, there are 4 pressurables, people. See, trade winds, westerlies and polar easterlies, this is the direction. Correct? Correct. But But if you take all those winds, apart from moving this south to north, this kind of variation, they were very, very close to surface. So this is my trade wind, this is my westerlies, this is my polar easterlies. Is it clear? You take jet streams are totally off. First, they are high altitude winds, which means they won't flow close to surface, far away from surface, like 7 kilometers, 8 kilometers, 9 kilometers above the surface. So they'll rotate like this. This is jet stream. This is trade wind, westerly, very close to surface, affecting events which are directly on the surface. This is very far away, this one. Okay, so my jet streams are at high altitudes and they're present above subtropical high pressure belts. Please remember high above subtropical belt, no? High above subpolar low pressure belts. So this is my subtropical jet stream. Subtropical jet. And this is my polar jet. Polar jet. Okay, high above. They flow from western side to eastern side. They flow from western side to eastern side. West to east. Is it clear? Same for north and south, so northern hemisphere and southern hemisphere. We'll see an animation, don't worry. Just copy this, I'll show you an animation. Simple 30-second animation. Just to visualize, it's quite difficult at the start, but over a period of time we'll get it. Flow from western side to eastern side. Okay. Tell me once you're done. We'll see the animation, then I think I can slowly pick up questions. It's not over. I'll come back to jet streams again. Cyclones, I'll need this again. Basic idea I'm giving you. One response, one more response, we'll just go to YouTube again. Okay, now. Just for visualization, just like we did yesterday for circulation. Okay, this picture can be closed. You've done this climate. Yep, closed. There it is, yeah. Jet stream. "30-second animation. Even the audio is not necessary. Just look at this. See, first big problem, Big problem is you need to know which is which. The thick band of air is fine, no? That is the high velocity wind. Look right now. See, they're moving from the North Pole and coming to the latitudinal view of the Earth. And you see that the wind system is extremely fast in dark red color. That indicates wind velocity. This is my jet stream. Fine. Long, narrow, fast flowing compared to the surrounding environment. So red color indicates a strict band. Fast flowing, meandering. That is my jet stream. High above, geostrophic wind. Okay. That's all. Is it clear? That's your jet stream. Is this fine? Now visualization problem is okay. Raj, is it okay now? Okay, fine. Okay. So, not there? Oh. Next week will possibly be handling. Next week, if we have geography, I don't know, provided they give 4 sessions. I'll finish air masses, temperate cyclones, comparison between tropical and temperate cyclones, all the remaining 7 climatic regions. We finish them. Then we will have only certain topics in climatology. Thunderstorms maybe, and after thunderstorms, that's it. Then we'll be moving to geomorphology. So effectively 2 more weekends I need. I'll finish geography for you. Okay. So now if any doubts are there, you ask me. Jet stream's direction is opposite to cyclones. Now please understand, if you're talking about eastern to western movement, yes, jet streams move western side, eastern side. Correct. So if anyone else has any doubts right now, yeah, that's correct. You're moving from, trade winds move from eastern side to western side, I'm very insistent of tropical cyclones because temperate cyclones again move from west to east. In that case, it is correct. And please note, cyclones are surface systems, jet streams are high altitude systems. I'll repeat this a million times, no problem, but never ever forget they are in high altitude. Is it clear? We'll repeat this, we'll come back to this again under temperate cyclones. Is it clear? Now, if any doubts are there, you can raise your hand so that I can get back. We'll deal the doubts through audio. Enable Panel. The other types of geostrophic winds are not of interest, man. Not great climatic systems. Jet streams are a big climatic force.
Sir, good evening, sir. Hello. Can you hear me, sir? Sir, one doubt here is you have talked about the fertilizers in the climatic regions of equatorial.
The plantation agriculture we saw.
Yes, sir. Can you just explain on it, sir? Because my internet network is very low.
Yeah, this was the point. Equatorial climate, due to high amount of rainfall, even though biomass is high, because the biodiversity is high in equator, high population due to temperature and rainfall characteristics. Even though large number of plants and animals die, in spite of humus, most of the nutrients get washed away from equatorial soil. That is what makes equatorial soils highly infertile, the reason being extremely high rainfall. Now, if you're going to do plantation agriculture in a region which has infertile soil, you cannot do it. That was the point I was insisting. So, be it Indonesia, Brazil, or Congo, they will need to apply artificial nutrients to support their plantation agriculture. That's all.
Okay, sir. Now coming to the second question, sir. Desert climatic region. The Chad is coming under the desert climatic region, or it's not coming under, sir? The Chad Lake you are told in the map reading portion. Chad.
Chad.
Yes, sir. MNC.
Yeah, Chad.
MNC you are told.
Chad is again a complex country. Northern part of Chad will come. Let me show you. Hold on. Let me just show you. Just a second. Not this. Chad will come under these. Northern Chad will be close to Libya. So there alone you'll get deserts. Apart from that, we have one more climate called savanna. Most of Chad is under savanna climate. It's tropical grassland. So there I can show you. We'll just hold on for a few seconds. I'll just know that Chad is a split country. Northern part close to desert, but most of the country is savanna, tropical grassland climate, which we haven't seen yet. Which we need to take.
Sir, as I told in the map reading, that the lake was dried over a period in the last 50 years.
Yes.
Is it due to the climatic changes, or?
That is due to climate changes because savanna experiences severe climatic problems. Let me try to pinpoint. Yeah, right there. You see that? I think you're able to see, isn't it?
Yeah, exactly.
So let me draw the border of Chad because you'll get the green color and yellow. This is directly from satellite, so you'll see this. So you clearly see that southern part of Chad is green, much greener, isn't it? So this is the area where there is tropical grassland. So from forest to grassland, there'll be a change. Most of Chad is a desert, like the larger part. Is it clear? But drying up of Lake Chad is essentially because of climate change. Okay, fine. So transitional country.
Sir, and one more doubt. Which are the materials we need to focus on in this today class?
Now it's quite simple. 4 chapters we finished today, right? Coaching Leon. 4 climates.
Yeah, okay, sir.
Learn the 4 climates. For cyclonic systems, I don't remember the chapter, but same diagram I drew For cyclones, we had cumulonimbus walls, eye of the cyclone. I don't remember the chapter number. It should be chapter 10 if I'm not wrong. Like now, if you go to chapter 10, you can just flip through the pages. The diagram will be given. And you can start studying tropical cyclones. Temperate, I will deal next class. Okay.
Sir, that is from Cochilia, right? You are saying.
4 climatic regions from Gocheng Liang, cyclonic systems from fundamentals of physical geography.
Okay.
Okay.
Okay, sir. Thank you.
Sure. Next person.
Good evening, sir.
Good evening. Yes.
Sir, in the beginning of, means after the break, you told about things, sir. Some classification that there's no need to read. What is that, sir? I
So
lost
it is
connection.
open classification. Let me write it for you.
Okay.
Because if others are listening, it will be useful for them more. So see, this is a chapter in NCRT, Fundamentals of Physical Geography, Classification of Climate. Chapter 12, I think, Classification of Climate. And under this, they'll talk open classification system. Please don't read this. Not required for exam. This is an optional topic. Geo optional students need this. GS students need it. UPSC is not asking questions from this anymore. You can
Okay,
say
sir. Other than that, we can read everything in that NCERT, no, sir?
yeah. Other than
The
that, it's fine.
fundamentals of physical geography.
For climatic
sir.
regions, Gocheng Liang will be enough. The orange color book you're using.
Okay, sir. Is it necessary to read Masjid Hussain, sir? That is not required.
Masjid Hussain is again I recommend for optional one. GS it is not required. GS we need constant updation only, and that current affairs part I'll give some material also, so that should be enough. No worries.
Okay, sir. And one general question, sir. There is a phenomenon called Northern Lights, no, sir? I guess it is in polar region or
Polar region. It's in the polar region.
so while dealing with polar region, you will
I'll
deal
be
that, no, sir, or?
dealing with it when we come to geomagnetism. It's a simple concept only. Under geomorphology, we have geomagnetism. So at that time, I'll teach you.
Okay, sir. Thank you, sir. That's all.
Sure. So next person can come. So thanks for the question. So no need to read that in your Fundamentals of Physical Geography book. So hold on for 2 minutes. If anything else is there, you can raise it, put up your hand. If not, I'll close in some time. Your call. Just let me know, people. If you're leaving also, let me know and leave. Don't simply leave. Participants are, how many participants are there? Still 15 are there. You should only tell me. And in the 15 participants, one is my mobile phone, one is the system here. Only 13 people are there. Hmm? Anything you missed, any net connection problems, anything on the line, you just tell me now. Okay. If you're leaving, just say thank you and leave. So that at least the participants list I will reduce so that I'll know that you are there or not. ஏதாவது சொல்லுங்க. Say something, anything. Leaving, just say thank you and leave. That's all. Your call. Basic difference between hot and cold desert is only temperature. That's it. Hot deserts have the average temperature to be high, and cold deserts are simply cold because you're very, very far away. That's all. You take Sahara. Sahara is a hot desert because it's very close to equator, right? So from the equator, let me take you very far away. Let's take South America, for example. So this is my equatorial forest, and this is very close to my equator. This is my Atacama Desert, this one. Right? So close to equator, average temperature will be high. Now let me just move further. You move away from the equator, this is Patagonia. This is a cold desert because nothing is visible, because average temperature is less. That's it. Basic difference between hot and cold desert is in temperature. Fine then. Okay. Raj, thank you for at least responding. Remaining 12 people. Make it 11. One more message. Okay. Fine. Okay, I think people are leaving now. Many thank you messages. Shall we close then, people? Only 10 are there now? Not even 10. Fine then, okay. So we'll close the session. Both the sessions I finished 15 minutes earlier. I'll take back later, no worries. Fine then, take care. It'll be nice if we can meet next weekend so that we finish the climate. We'll see how the timetable comes. Thank you for now. Bye.